as you continue on in your software degree, when you get to a class called object-oriented programming, this will make a lot of sense why, but you don't need to worry about that now. But just follow the convention. You got a variable, and the value inside is going to change. You make it lowercase. Another thing about variables, cannot start with a number. A variable name called like x1, that's good. 1x, bad. And the reason why is when Python reads through your code, and when Python's reading through your code, if it sees a number, it's going to try to basically look to see the rest of the number. So that's why you don't want to have variable names that start with numbers. I see people on the stream that are asking if everyone on the stream is muted. So the audience of the stream does not have voice channels. If you have any questions, put them on the text channel and we can address them that way. Okay. So another thing about variables is that you absolutely do not want to set a variable to have the same name as a reserved word. So cannot share name with reserved words. Some examples are like def. You don't want to have def as a variable name. You don't want to have a list. Oh, I saw some of this on some of your labs. You were setting list to a variable name. Don't do that. That can cause some issues. Maybe not in the labs, but it does have a good possibility if you use list as a variable name. You don't want to do that. You want to use like LST instead, or capital. Actually, not capital. You don't want to start them with capital, like LST or list1, some stuff like that. Like int, if, float. These are reserved words. Don't set your variables to that. Sum is another one that I saw in some of the labs. Some people used sum as a variable name. Don't do that. It can cause issues later on. Okay, and where the variable is defined matters a lot. So this is frames defined in global frame versus defined in a function frame. And you just got to know, like, when you are looking for a specific value, or when you're trying to get a variable, you look in the local frame. And if you're inside a function frame, you don't really have direct access to the global frame. You have to get stuff from your global frame through parameters. Okay. Now let's talk about calling functions. So calling a function is fairly simple. Let's say we can jump over to Wing. This will be to show that the frame that a variable is defined in matters. And I'll definitely post this little Python document up in the Discord later on. So we'll all be good on that. Okay, let's say we want to hop back to here. We want to call a function. Well, how do we call a function? We call the function by having a line with the function name immediately followed by parentheses, maybe with the params. Okay, but not every function needs to have parameters. Maybe here's an example of a function that doesn't have parameters. Def, let's say print hello, no parameters because we don't really need them. And if this function just says print hello, and then on the next line we can put like a call to it, print underscore hello in brackets like that. We should see when we run this, hey, it calls the function and that call is on line 14. Okay. Oh man. Yeah. Okay. Now I see in the chat that you guys can't see the wing. Okay, I'll change that real fast. Just getting familiar with this OBS stuff. OBS. And we can call the OBS. Now you should be able to see my wing screen. Okay, we good? Yep, awesome. So, not all functions have parameters. If they don't have parameters, you just have no brackets in there. But you can't just say the function alone, because that will be unnecessary to have parameters that deal with that. Okay, so let's go back to the doc screen. Okay, now let's oh geez, so we do got some people who are saying that it's very early in the morning, like 1 a.m., meaning there's the sun has gone down for a while. We could be here for a while. Given with all of our technical difficulties to start us off, it could take a while. But we want to wrap this up, like preferably before. This is all recorded, so I'll post a video link later on as soon as we get the total video link. So don't worry about that. If you do have to go out in the middle of the session, I will post a video ASAP fast as soon as we get the chance. Okay. So if you are like, in a time zone where you're already starting to be very tired, the video link will be available. Okay, so let's move on to our function definitions and our docstring. Someone's asking where is it posted? It'll probably post it onto YouTube, and I'll just put the link into. I'll put the link in the Discord after I post the entire video. Okay, but let's keep it moving and let's get into the function design recipe. Function design recipe, this is going to be quite important. I imagine that since you have been tested so much on this in your labs, it is very likely that you will see similar stuff about the function design recipe on your final exam. Okay, so let's pop back to my wing screen and keep it moving down here. And I'll make a new comment section saying function design recipe. Okay, so function design recipe. Well, we can't say function without fun. Let's write out our steps. So our step 1. Let's see if anyone in the chat can tell me step 1 of the function design recipe. We don't necessarily need to follow word for word of the book, but yep. So people are saying examples. Expected behavior of the function. Okay. So we basically these are going to be our test cases. And typically when you write functions, you're going to want to test them before you give them to anyone else. You got to make sure that they work. No one wants to be given a non-working function. So first we got to start off with examples. Awesome. Step 2. What do we got for step 2? Let's see if the chat knows. Header. Yeah, I guess that could work out. Docstring, well, this is all kind of parts of the docstring, but yeah, we could do the function header. Now, the specific order that you do this is not super important. Like, you could do the function header before you do the examples, but we could just follow the book. The function header, like this is the definition, and you want to comment or have indications or indicate the data type of the parameters and return value. Okay, what's the next step on the menu? Yeah, so docstring, what the function does. So docstring description, basically. Of what the function does. Yep, so we always want to describe what our function does. Otherwise, no one knows what's going on, and that's not optimal. So we want to have a docstring of what the function does. The next thing on the menu is what? Let's see if the chat knows. First person to say it gets 5 respect points. Test, well, it's hard to test if we don't have, the rest of the function. Yes, body. It's the step 4. Write out the body of the function. Okay, so let's run through an example, and we can run through our function design recipe. This will be important because if you miss any of these steps, they will be deductible. Those will be deductible mistakes that can lower your mark and lower your mood. And you want to be very happy when you finish the exam, so try not to have anything in there that will lower your mood. Yeah, so writing the body of the function is basically the same as implementation. So let's say our problem is, let's make a function that increments or that returns an int of the input parameter squared. Okay, so let's just leave a blank area for our docstring. Let's now, what's a little bit backwards about how the textbook teaches you your function definitions, to do the function design, to do the examples before you do your docstring or your header, you can't put the docstring in the proper place before you do the function header. So I think, honestly, you should do the function header first. That's my opinion, but, they're testing you on the textbook. But it just makes a lot more sense to me if it was the other way. So let's do this example. Let's do the function header first so we can put our docstring in the right place. So let's say our function, well, it takes the input parameter and returns the squared version of it. I think square is going to be a reasonable name for it. And what does square need? It needs the input, right? So we're going to have an input parameter. Let's call that n maybe, or number. And we know that number is going to be what type? The input parameter has got to be some type of numerical type, right? So we can say int. Yep, a lot of people in the chat are saying int. I like the way you think. And it returns an int on the output, so that we just, it returns an int. Cool. So in our docstring here, let's do some examples. Yeah, the beeps in the background, I think that's for my own Discord notifications. I can mute those for now, or I can make them not broadcast hot onto the stream. But I will need to turn that back on when my coworkers take over, because they will be going through the same stream, except I'll be streaming like their screen share. Like, it's gonna be a little bit indirect, but we'll make it work. I promise it's gonna work out good. Okay, so let's start off with some examples for square. Let's say we have square of 3. What should we expect? 9. Ha. 9. That's 3 times 3. 3 to the power of 2. 9. Makes sense to me. Let's do 3 examples. I'll actually copy this and paste this so it's just a little bit easier on us. Okay, let's say we have the square of 25. With some quick mental math, that's 625, I think. Yep. Okay, the chat agrees with me. Good job. And if we wanted to square, if we square a square of 3. What's that going to be? That's a brain tester. So that means, yep, 81. Amazing, chat. So the reason that works out is because the inner evaluates to 9, and then 9 is going to be the new parameter to the next square out there. Hey, someone said that's illegal. That is not illegal. This is just a spicy test case. Okay, now we need a description of what the function does. Let's describe what the function does. Well, you can basically get this from your problem description. We can just like edit that a little bit. Returns an int of the input parameter squared. Yeah, seems reasonable. Seems like a reasonable description. Awesome. Yeah, okay, so the next thing on our menu, write out the body of the function. Well, we got to return something, right? And we're always going to treat the input parameter the same, regardless of, its number. Like, even if it's like a negative number, we should expect this. Oh, I can even change that example. Like, if the example is negative 25, we should still expect 625. Okay, so for the body of this, I think it should be fairly straightforward to see that it's just like number to the power of 2. Or we could just do number times number, but it takes a little bit less typing if you do to the power of 2. And that could be our function design recipe. So if we want to see that this works, this would be what you would call manual testing. So, we go into the shell square of 3. Does that give us 9? Oh, it sure does. Square of negative 25. Hey, that gives us 625, just like we expected. And square of the square of 3, 81. Awesome. Someone's asking if you use the power function. Feel free to use power. Actually, if you use like math.pow, I think the return value for that is always going to be a float. So it might be better to use this because you know that to the power of 2, when it's appropriate to do so with integers, it will always return an integer. Whereas if we did something like pow, like 2 to the power of 8. Oh, I guess pow does work. I think maybe I'm just thinking about a different thing, but you want to do your testing here to make sure that your output type agrees with your function description. Sounds Gucci? Awesome. So that would be like a very simple example of how we run through our function design recipe. But of course, like, later on, we're going to see some much more intense examples, and that will be, we'll follow the exact same procedure for designing those functions. Okay. So that's not the one. So back here, a function design recipe, documentation matters a lot. The reason why is because it's very rare that you'll ever be working on a software project completely alone. You will need to collaborate with a lot of your peers, typically. And when you collaborate with your peers, you want to have good documentation so your peers know what's going on. If your peers don't know what's going on, well, it's going to be hard to collaborate properly, and you're probably going to crash the boat, and you don't want to crash the boat. You want it to be smooth sailing. And indenting, just make sure, like, what an indent basically indicates is that, like, everything beneath here is going to be somehow like a child to like the unindented line, or the thing that is one indent less deep than it above it. Like you might have, like, how like if you have an if statement, if true, like you'll have something in here that just like the indent just indicates like the relationship of who's more powerful than it, or like who needs to be run before what's underneath the indent goes. Indenting problems, I've seen some people got marked down in their labs for that. So be careful with your indent, and always use tab instead of space. Because I've seen some people use space, and that can be problematic. Okay, so indenting and why it matters. Use tab instead of spaces. Okay. So I think I'd like to now pass the microphone over to Pranav, who will cover some stuff about strings and Boolean values. Pranav, can you say something? Is the mic should be hot?
Yeah, I believe I am audible.
Chat, can you say something if you hear him loud and clear? Okay, so Pranav, I'm gonna stream your screen share.
Yeah, I think it should take you back to the same Google Docs document.
Yep, just make sure your screen share is on. Mics are hot, and I'll be here and loading up your screen share. It's taken a while to load up, which is a little bit of a concern because maybe my internet bandwidth is not intense enough to handle both. Oh, okay, I see it. We're good.
Okay, good. So we went through some data types above when Milan mentioned about all the data types we have. And to start up with, we'll be looking at strings first in specific. So why do we have strings is the question. And I would say there are a lot of times that we use all these numeric values in ints, floats, and in other languages, you'll probably see more data types called doubles and all that when you move on with your programming courses and all that. But generally the boundary with all these is you can only do some arithmetic stuff with them. A lot of the character based, language based, like printing stuff and all that cannot be done. And there are times you probably might want to print sentences, words, and all that. And numbers don't work that way. So we need alphabets, we need characters, special characters, and all that to be put in. So we have a special data type, which is strings, and we represent it by str in Python. And generally, any string value that we have, we enclose it under double quotes. So any field that we have inside this double quote region is what we are essentially calling our string literal. And we can generally store any sort of a character, word, sentence, phrase, special character, even numbers. So when you don't want to use numbers as sort of any mathematical or arithmetic ways, then you can always use these strings and just print out those numbers the way just as they are. Now, since it's a string type, so Python automatically detects what type is that variable based on the literal value that we attach to it. So if I say I have a new variable which is called s and I give it a double quote, so now Python knows that this is a string. Why? Because I've attached some value to it in double quotes and my string value is actually hello. And what string allows us is, we must have seen this in all the print statements that you have. We were printing stuff like print. In automated testing, we did a lot of stuff like print test passed. And here, actually, we were telling print that you need to print this string literal, which is test pass. So this double quotes is an important factor. If you don't have the double quotes, you might run into errors because that's the defining point that this is a string. And generally, by convention, when your string has just one character, like an H or a 1 or something like that, then we generally put it in single quotes so that we can identify that, yes, it's a single character. So then it's a single quote, as in this way. So that is another variation that you can do with strings. Of course, you can have more in this, that single quote and double quote is an equivalent boundary. But by convention, we follow that double quotes means there's more than one character possibly, and single quote means there's just one character. It could be a number, a letter, a special character, anything works. Now, we discussed why we have strings, and it is important to see why do we actually use them and how we use them. So in your labs, probably lab 2 and 3, you might have been through stuff like string concatenation, and printing those multiple strings. And we'll just do a very short review on all those things, that what operators can work with a string, and how can you manipulate strings, use strings using indexes and print them, and some example questions that I have here down below will showcase you that practically. So concatenation basically, if you see the English grammar term of it, it basically means you're combining two things. So here we are combining two strings into one. So if I have a string which is hello, and I have another string which is world, basically A plus B is a concatenation operation on the strings A and B. And what A plus B essentially means is a new string which is hello world. Now that's how we basically concatenated or merged those two strings together. And actually we don't have spaces here, so it would be like this hello world. It's like stuck into each other. But if we had a space either here or we had a space either here, that space counts, and then we would have had hello space world. Another one, you can call it duplicating or multiplying strings, just not the mathematical way of multiplying, but it works pretty similar to how you do it in math. It's just now you're duplicating strings. So again, if we have a string called hello, and we say A is equal to A into 3, essentially this means is we are having this string 3 times, and A into 3 is getting stored in A. So A into 3 essentially would mean hello 3 times as a string, and then we store it in A. So it should come out as this. And I'm pretty sure this is something you guys would be familiar from the labs. And if you want, let's do a quick test of this on the Python shell. Yeah, I'm just switching over there. All right, so you should probably see my Python ideally shell. So let's say we have our same string hello, and when you print, oh, okay. Okay, so we basically have a string which is a hello, and if you try and do a print on a, basically you get back your string. Now let's try and do our concatenation. So let's add a new string, world, and let's say C is equal to A plus B. And essentially when I print C, we get hello world, just as we expected when we were sort of going through the explanation on Google Docs. Similarly, if I say D is equal to A into 4, and I say print D, we should have hello 4 times, and that's what we technically get. We have hello 4 times. Now, coming back to the Google Docs, where we talk about the next thing, which is indexing through a string. So as soon as you see my Google Doc, you can say yes on the chat, or Milan can let me know. Okay, good. So indexing individual characters in a string is the next portion. Basically, every string has some size. So if I have a string called hello, it basically has a size of 5. 1, 2, 3, 4, 5. So the size or the length is 5, but a very critical aspect in programming is the index and the count of length is different. So the indexes start from 0, whereas the count for length starts from 1. As a result, if we have a string called hello, then its indexes would be 0, 1, 2, 3, and 4. And basically, H gets index 0, E gets 1, the two L's get 2 and 3, and the O gets 4. And if you use the count, like if you use the length on it, len str, and then you'll actually see it counts H as 1, 2, 3, 4, and 5. So the length is actually 5, which means index is always length minus 1. And this is a very critical aspect, and this is a mistake which is very common when you try and access the specific elements of a string, and we will get on that next, how do we access that. But this is a very critical thing because people tend to make those errors in strings as well as with arrays, and basically that area is where they get confused which index is what and how index is different to a length. So a size 5 or a length 5 does not mean the last index is a 5. The last index is actually 5 minus 1, which is a 4. And the first element of that string or array is not the index 1, but it's actually index 0. So it's a very common error. We've noticed it in the labs, and it's very general. People can sort of miss out on that very small detail, but it's very critical. And an error on that could lead your program to terminate or fail. It generally gives errors like index out of bounds and all that. So moving forward, let's just look at how do we access a specific string element. It's very similar to how you might have possibly seen it in arrays. String is considered like an array in a broader sense, an array of multiple characters and stuff, but we won't talk about that much in detail. We'll just show you a similar way how to access string elements like an array. So again, let's say we have my string a, which is equal to hello, and I have another string or character literal, say letter. And what I'm essentially going to do is I'm going to assign it the letter that I have at position 1 on my string A. And what it actually does is letter tends to get assigned with the value E. Now, why did this happen again? Index 1 of A is actually E. And we say letter is equal to index 1 of A. So letter gets assigned with E. So that is a way of indexing through your string and accessing multiple elements that are inside the string. So if I put it as 2, this E should get replaced by L in the letter. If I say 4, this will get replaced by O. And what if I say 5? Now, if I say 5, this should turn into an error. And that's because there's no 5 here. There's no index 5 here. The last index that we had was a 4 because indexes are always length minus 1. So that was indexing individual characters of a string. So you can store them, you can use them, you can do multiple stuff with them and conditionals and all that we are moving forward to next. So first, we have a small example question, which is make a function with 3 string parameters that prints and returns the 3 parameters concatenated with each other with some spaces between them. So following FDR, basically what you need is you need to create a function which is def. I can name it concat. Actually, I'll switch it to wing. Let me take this to wing.
Loading it up. Just waiting on you. We see your wing. You look good.
Okay, good. So since Milan already discussed about some FDR stuff, I already have that FDR sort of function header with the proper name, some type parameters, and a nice doc string which says that we are returning a new string after concatenating the 3 parameter string with spaces between them. We have some test examples. String 1 is hello, string 2 is 1041, string 3 is review, and what we essentially need is hello space 1041 space review. So how do we go about it? So pretty simple. We can do it in 2 steps. We can do it in 1 step. Let's try with 2 steps for simplicity. So let's say we have a new string which is called conc. And what I'm essentially doing is I'm adding the 3 strings together with some spaces between them. So space on its own will be a string. So let's say conc is equal to str1 plus a little space and plus str2. So str1 and 2 and 3 are basically the parameters I got when I called this function. Plus again a space and str3. So basically what we've essentially done is we have added these 3 strings together, and now we can simply return this new conc string that we created. And basically we can test our function once now if it does the same thing as expected. So using the test cases we had, yeah, so we are good because we expected when we wrote the doc strings that we should get hello 1041 review, but there should be spaces, 1 space between each string, and essentially that is what we get. So this function looks good. Anybody have any questions in the chat on this?
I think we're good.
Okay, perfect. So next up,
someone asked, is there another way to add a space?
I think there's a built-in function called white space, but generally for simplicity, I would think it would be better if you add manual spaces, or you can also do one thing, which is put your space as a constant, and that is also a good way sometimes. And instead of this plus blank space here, you can do a plus space every time. So that would be a good thing too. Third way, and this would be only making things more complex compared, like for the thing we have to do here, is you can use loops, or you can use a while loop and say every time you have added a string, you add a space to the conc. So it's just complicating things because we just have 3 strings, but yes, there's a lot of variations to do that. You can have your space as a constant. You can physically type in that space in a blank quote. You can use loops to automatically add a space to your conc every time it's added, but that's more of a loop program than just a string-based program because it's essentially not needed. It's just making things complicated. Does that answer the question to some sort?
Uh-oh. Okay, 1 second. I'm gonna reconnect.
Strings and some conditionals, but before that, I'd like to talk a little about conditionals.
Can you rewind for a second? I accidentally logged off. Just rewind for a second.
Yeah.
You were just saying that like adding spaces, like with the way that you're shown right now, um, that's pretty much the easiest way that you can do it. Any other way would pretty much just complicate the stuff. But yeah, that's
Yeah,
what you were
like,
saying. Yeah.
yeah, because the other way would be like I showed a constant. That's a very equivalent way that can be very easily done. Any other way would sort of be like you're complicating things with the loop or with multiplications and all that in the string. And we just have three strings, so it's very easy to add it that way.
Good.
Yeah, I'll move to the Google Docs again if you can switch that for once, and we'll talk a little about conditionals.
Okay, we see the docs. You're good.
Good. So conditional is an important part. Why? Because it helps us sort of compare things and make some decisions. And every time you reach sort of a point where you need to decide which path you need to take, it's very important to make use of these if, elif, else. These are the three conditionals we have in Python. And we can have multiple problems which could say that if X happens, do A, if Y happens, do B, if Z happens, do C. So there has to be some way to check if that X or Y or Z is happening, and basis that correspondingly we'll do an A or a B or a C as their outputs or as their subsequent processes. So conditions are a way for us to check the current status that we have, because we could be checking values, we could be checking input values, some values that we processed and we want to take them forward, or we could be just creating some outputs based on what we got from the input. So they are a way for us to check the current status of the program, or they can be used to implement features or outputs based on the inputs received. So we have done multiple such exercises in the labs where we have said that if the bill amount is greater than $100, we give you a 10% discount. If it's greater than $50, we give you 5% discount. And if it's less than $50, we give you no discount. So at every point, we're basically checking what feature can be implemented based on the bill amount we have and how much discount are we giving. So the general syntax for an if is an if, and there goes your condition, and this colon demarcates that that's the end of the condition. And as we know, indentation is important, so we know what portion of the code is there. So here could be statement 1, and you could have many such more. So you could have just one statement in your if, or you can have even more, like statement 2 and so on. Now, it's not necessary that you only have one condition. You could have multiple conditions which are subsequent to each other or even separate. So let's say if you have subsequent conditions, like a bill amount is greater than 100, that's one condition. It is between 50 and 100, that's the second condition. And third condition, it's below 50. So if condition 1 does not satisfy, we should essentially come back to condition 2. And there we use elif, which essentially means an else if in short format. So if condition 1 fails, we come back to condition 2, and then we have some statements 1, 2, and 3 for this condition, obviously in different lines. So that would be statement 2. And you could have statement 3, and you could have many more. So depends on how many processes that you need to do in every condition, what changes you need to make, what variables you want to add, change, increment. You might also need to call different functions on different conditions. So there's a lot of scope that you can do with different things. The goal of an if, elif, and else is always trying to gauge how you need to manipulate your outputs. And obviously, there's always a last condition that you have when all conditions fail. So we could have multiple elifs, but if everything fails, all conditions are not true, they don't satisfy, we finally have an else that decides, okay, something at the end finally that we do if nothing works. So it could have its own sentences, statement 1, statement 2, etc. So that's if, elif, else in very brief. And basically in all these condition areas, we're checking, comparing two variables, two values, two literals, seeing if they are equal. I'm sure we have seen this a lot in our labs where we're trying to compare if two values are equal and then saying a test passed, a test failed, all those things. So a very short review on that. And or parentheses in logical equations. So there could be situations where you have conditions which are sort of compound conditions. So you have a set of statements which should be done when either condition 1 happens or condition 2 happens or both conditions happen. So we use and or in such kind of conditional equations. And how it works is, depending on our objective, we decide the conditions to be applied together as a compound condition using and/or logical operators, I would say. And generally, that is the place where we sort of get into the Boolean situation of things, where everything is either a true or a false. So Boolean is basically a very binary sort of a data type. It only works in true or false. There's no other value. It's just true or it's false. And it helps us make a lot of those decisions, that it's basically every time a condition is satisfied, using our logical operators of equal to, greater than equal to, less than equal to, not equal to, which Millen described when we were talking about operators. Each of these actually result in a Boolean true or a Boolean false. So let's say we have two variables a and b. If a is equal to b, what this gives us is a true. And if a is not equal to b, we will get a false. A different way of saying a is not equal to b is this one. Now here we are checking if a is not equal to b. So this should give us a true if a actually is not equal to b. But if a is equal to b, this gives a false. So you see, like, a not equal to b and a equal to b are sort of inverses to each other. And similar way is the greater than equal to and a less than equal to. And these are basically logical operators that return you Boolean values, a true or a false. And all these conditions come and get set up as outputs in our if and elif. And what an if does is it just checks that if the condition using these operators gave us back a true or gave us back a false. And if the if statement feels that here what we got after that evaluation is a true, it uses these. If that is a false, it goes and checks the next elif. If that is a true, if it evaluates these. If it's a false, it goes to the next elif if we have any. Or if all ifs have failed, we finally come back to the else and we execute these. So that is a mix of conditional with Boolean, how these Boolean operators, logical operators work with if and else, and help the program decide what statements need to be executed. So I had a function example here.
Pranav, we have some questions on the chat. Maybe we want to address those before we go on to an example.
Yeah, I wasn't seeing them yet.
Okay. I think the first question was asking.
LF, yeah, I'd address that.
Yeah. Is it cool to
just use if only? Yeah. So if you have like subsequent conditions, it is always like you'll have to use else if in that case. So let's give you an example. Moving back. Let me put it here. So let's say if I have a condition where bill amount greater than 100 is a 10% discount. So if it's less than, and my next barrier is 50, so bill amount greater than 50 is a 5% discount. Now, technically these are subsequent conditions. Why? Because if my amount is greater than 100, we give it a 10% discount and we evaluate it using the statements we'll have under that if. And if it's not that, we'll come to our next condition, which is this one. So for this condition to work, technically, the previous one has to fail. And the boundary of this condition indirectly would become 51 to 99, 51 to 100 actually. Why? Because this caters to 101 and above. And this shall cater to 51 to 100. So it's a subsequent condition. Why? Because the failing boundary of this comes to the next one. And now we have a new boundary in this one, which goes up till this one. And this is the starting boundary for this one. So in this cases, we need an LF. Why we need an LF? Because if you just have an if, you would probably execute this one, put a 10% discount. And if you have an if again, your amount is still greater than 50. And you will put a 5% discount again. So that would lead you into errors. Why? Because your amount was above 100. You used it for this condition. And then again, you're using it for this condition. So you're checking it on different conditions, having it true on all conditions, and then you're giving some extra discounts. Probably the customer would like that, but the merchant won't. So that's why we use the else if we have subsequent conditions where boundaries are limited. But if it's all independent, probably not for a bill amount, but if we have a case where the first condition and what we're doing there does not affect the second condition at all, yes, then we can use separate ifs. If that helps, you can put a yes on that.
Yep. We just talked about it a little bit in the chat, and I think it's understood. elif cares about what's upstairs. If doesn't care about what's above it. That's pretty much it.
Yeah, true. Yeah, basically, if you have if you have any of the if elif conditions satisfying, your program basically executes those statements, skips all of that if elif else structure, comes to the next thing, whatever now you have after all your else statements. So it straight away comes to whatever you have in the XYZ statements and all that. But if you have separate if statements, basically your program would go through every statement, evaluate that, execute that, then go through this statement, evaluate it, and execute it if it's true. So subsequent ones, we need an elif if we have those ladder sort of.
If you have to take one path and taking one path disqualifies the other path, use the elif. But if you want to check multiple paths and you have the ability to go down multiple paths, that'd be the if. Yeah.
Yeah, it's important to check the structure of the requirements because you get to know if one condition affects the next one and if they have common boundaries and all that.
The next question that was on the chat.
That was logical operators.
Yeah. The next question that was on the chat was Do we have to return or reduce multiple if statements to a single return statement if possible?
Yes, that is a very good practice that should be done wherever possible. So basically, this entire if statement. So there are cases where you're checking just one thing and you're returning just one thing. And we did this in the lab 9 exercises where we had to sort of refactor all those multiple if-else statements and put them in one line. So yes, wherever it's possible, wherever you can put in multiple conditions which correlate and produce the same results, you can do that. In this example that I took specifically, we cannot do this, I guess. And why? Because every condition that gets satisfied has a different discount. It could be 10%, it could be 5% on the next one, and it could be none on the third one. But yes, where we have conditions which sort of correlate and I can have all three true or even one of them true to do something, that is a good place where we should have just one return statement with all the ifs together combined. That would be a good reduction of the if-else ladder, would make your code concise. Yes. Any further questions on that? Yeah. 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 Else is basically the last condition that if everything doesn't work, you go to an else. But you necessarily don't need it. If nothing works, whatever code you have below that would still work. But it's just sort of separating that, yeah, if that part of the code is different from what you have after your if else structures, then yeah, then we have an else. But yeah, not necessarily to have an else always. Okay, next. So I'll look onto this example where we have a function that checks if a number is even. So I'll switch to Wing again. And probably should be live. Yeah, I did that. Cool. Okay. All right. So we are having a function which is called even num, and it takes an integer value and returns us a Boolean value. So it should return us a true or a false basis our number being an even or false if it's an odd number or not even. I'm not putting some test I can put some test examples. Okay. So let's say even num and we give it 2. So this should return us true. Even num, if we give it a 3, this should return us a false because 3 is not an even number based on how we know of math. Okay, so first thing first is every time we create sort of something like a function or we write some code, we need to understand what is the logical or mathematical reasoning behind it. So the reasoning behind a number being even, how we know is it should be fully divisible by 2. So what do we essentially mean by fully divisible by 2? Can anyone answer that in the chat? If something's fully divisible by 2, how can we check that? Perfect. Yeah. So we use modulus. So what does modulus give us? Modulus gives us a remainder of whatever we had. So we can use a modulus to see if, so we're using a conditional that if my number is fully divisible by 2. So if n mod 2 is equal to 0, I can say return true. Else, I shall return false. So very simple program, just a 2-line code. And what you essentially just do is you return a true or you return a false if a number is even. And if we run it, even 2, that should give us a true. That's what we expected. It's a true. Okay, moving to the third example I had, that is mix of string and some conditionals. And it would be a good example to look at. It is about having a name and printing the initials. And this actually uses string indexes, it uses conditionals, it uses string concatenation, and it actually also uses for loops. So I'm having this right now, but if you have any questions on the for loops, probably when Matt goes over for loops or Bardia goes over for loops, you can have some clarity on that more. Anyways, so we get a string. Yeah.
Something I want to mention is you could actually refactor your previous function to just return the condition, right?
Yeah, definitely. I can do that. Yes, exactly. So here I can do that. I can say return n mod 2 equal to 0. And that's all, I guess, if I did that right. Yep. So n mod 2 is equal to 0. This should create a true or a false because it's a logical operator. It gives it that value to the return, and the return gives me back a true or a false, depending on what we give it in. So nice. Yeah, that was an example of the refactoring it into a single return statement. Coming back to the initial name that we were just starting to discuss about. So we get a name. So that's my name, for example, Pranath Pathak. And we want to print out the initials with a dot between them. So P.P or an example, John Doe, so J.D. So how we go about this? And the thought behind this is, when do we find an initial? An initial we find always after a space between the first name, the middle name, and the last name, however long your name is. So let's say my name has a first name and a last name. My first name and the last name have the space between them. So after the space, the first letter of my last name is my second initial, and the first letter of my first name is my first initial. An easy way to think of this is, let's work it all around spaces. So every time we get a space, the next one is the letter that we use as our initial. So let's do this. Since my first name, first letter does not have the initial space before it, let's give it a space so that we can completely work consistently along the spaces. So let's say full name is equal to a blank space plus the original full name we had. So full name is basically the parameter we have in this function. All right. Now what we essentially have is we have a space, we have the name. All we need to do now is separate out the first letter of the first name and the first letter of the last name. And we'll essentially need to go over through the entire string here. So we'll create a for loop for I in range length of my full name. Now, I'm pretty sure this would be a point where a lot of you would think, why did I use for I in range length full name? So let's think of it this way. Whenever you use range, you're essentially creating some indexes. And when you use something like a for I in full name, you're basically accessing the specific positions in that string. So we can actually use it both ways, But since our work is more towards the indexes, why? Because every time we get a space, we need to access the next one to get that P or get that D or get that J. So that's the decision you need to make when you create a loop. Are you going to use indexes or are you going to use just the elements? If I use just the elements, I get these letters. If I use the indexes, I can see the letters before, after, in the end, in the beginning, and all that. So we'll proceed with using the indexes. And now all we have is a very simple conditional. Obviously, since we are returning a new string, we can create that new string here so that it is nicely initialized. And now we just check that if full name I is equal to a blank space. Basically, what I'm doing is my loop goes over every single letter of the string I put in. And as soon as it gets a space here, it basically creates a true here. And what I'm going to tell is add the next letter after that space to my initial string. So I'm going to say initial is equal to initial plus the next letter I have in my string. So that should be full name I plus 1, because I is the space, so I plus 1 will be the next one. Plus, let's say we have a dot to get a j dot d dot or a p dot p dot. So simple. Every time we add it to our initials and we go about it that way. And in the end, all we need to do is return the initials. Obviously, make sure you return outside your loop because your loop has to go through your entire string. And we can test it once. Hopefully this is good. So let me try putting in my name again. Make sure when you send in the arguments, it is a string. You don't type it without the blank quotes, otherwise it won't be a string technically. So yeah, we got it as expected. I get back a string p dot p dot as we expected. And yeah, so a mix of loops. I'm sure you'll see the loops in detail in the next section that Bardia covers. But yeah, conditionals, we checked if it's a space basis a true or a false that we got here. We added something to the string. We used some concatenation. We had a blank string. We added that first letter of the first name or the last name. We added a dot to it. And then we finally returned it. So that was, I felt, a good example to look at all the 3 or 4 things that I was covering a short while ago. I guess that is good
we got some questions in the chat to
yeah, sure, yeah.
So the people were basically asking what was the process of going through the loop. I think the next person on our list of how do we cover this is going to go into loops more detail. But
yeah, I'm sure loops will be more in detail about if the confusion is about for I in range or for I in some list or some string, yes, that you'll probably get more clarity on that in detail. In case you have any questions for me regarding why I added a blank space or why I checked for the blank space and how I find the initial letters on that, put in that question right away and I'll help you on that.
I think once we go over loops, like this will be very, very clear to us after we cover loops.
I guess we can always revisit this one. I'll post it on the doc or edition if anyone wants to revisit that.
Yeah.
Also, I can explain it. Like when I explain my loops, I can come back and explain your solution again.
Yeah, perfect.
Okay.
Yeah.
Okay.
Okay, so we're good. I think Bardia can take over if he's next.
Sure. So should I share my screen?
Yep, turn on your screen share and
Okay.
And,
So you should see.
mics are hot and floor is yours.
So do you see the whiteboard thing?
Loading it up. Yep.
Okay.
I see a whiteboard.
So yeah. So essentially when you're talking about loops, so as you all know, we have two types of them. We either have while loops or we have for loops. And that's where most of the confusion happens. You're like, which one should I use? So when you're using while loops, they're generally used when you have a certain condition that you must follow. So you don't necessarily know how many times you want a certain things to run. You just want to say, I want this to run until this condition is met. So for example, let's say you say while A is smaller than B. So this whatever that is inside this piece of code will keep running until this condition is met. And then let's say you do something inside your program and suddenly A is not less than B. A is like equal to B or A is bigger than B. So the moment this happens, this program will exit. So this while loop will exit, and then the rest of your program will continue. So this is what we use while loops for. We use them for when we have a certain conditions that we must follow. But let's say you don't have that condition, but instead you're told that you need to have a loop that runs a certain number of times. Like let's say you want to go through an array and you already know that that array has 5 elements. So you can easily just say for I in range of 5. And what it does is that it just every single time it makes I equal to a certain value. So it makes it equal to 0, then 1, then 2, then 3, then 4. And it just runs 5 times, as you see, because it goes from 0 to 4. And the moment I hits 5, it just exits the loop. So this is when you know that your program should only run for a certain number of times. But sometimes you don't necessarily have that time, but instead you have you know that your program should run through a collection. It should run through a list, for example. So you can just say for I in L. And when you say for I in L, this is assumed you already have an array of some sort. And every single time that this program runs, this makes it equal to that element of the array. So the first time I is equal to element 1, then I is equal to the second element, then I is equal to the third element. And this new array doesn't necessarily need to be numbers. It can just be an array of strings. Call this A, for example. It can just be an array of strings. And then when you say for I in A, for example, so the first time I is equal to A, then the second time I is equal to B, the third time I equals to C. So this is extremely useful when you have things that you can't necessarily find the index of. Like let's say you're dealing with sets. And as you all did in lab 11, if you have a set that's like 1, 2, 3, set.0, this just gives you an error. You can't use that. So you can't necessarily find a certain element of a set because sets are just not numbered because the order doesn't matter. So the only way that you can access a certain element in a set is using this method. So if you are dealing with sets, this is your only option. If you're dealing with lists, you can use both options. And depending on your program, one of them would be easier. And I noticed in the labs, some of you used the first option and got stuck doing this second option. So for example, you use this option, and then halfway through the program, you were like, oh, I need this certain index to deal with it. Like let's say I want to swap values, or I want to see what value is I'm dealing with. So I need that certain index. And then because you use this method, you didn't have access to that index. So I say your first step should just be to plan out your problem. So if you want to have a tree here, so you can just have like just if the number is known. So if you know how many times you want to run, your option is for loop. And if the number is not known, you just have to run till the condition is met. Your option is while loop. And this is kind of where it ends. And now in the for loop, if you need the index. I'm just gonna call it need the element. So if you only need the element, you can just use the second method for I and L. And if you need the first method, if you need the actual index, you have to do for I in range. Now and then for example, if you need the element or you're dealing with a set. So this is your option. One more thing that I wanted to say, this is just an FYI thing, but I feel like it should help some of you. So range itself gives you a collection. So when you say range of 5, well, to be exact, you have to call it list of range of 5. But in general, it gives you 0, 1, 2, 3 to 4. So even in the time that you're saying for I in range of something, it's still going through every single element of a collection. It's just a different type of collection. So range, the way for I in range works is the exact same way that for LM in list works. It's the exact same thing, except range is just a sorted collection that goes from a certain number to another number, and every time you just set that element equal to that number. Now, do you have any questions? Should I go over any of these subjects again? If not, I have some sample questions I wanted to go through. Yeah, I just see a question. Is it possible to get a certain index of a set? No, and there's a reason for that. Because sets are just not sorted. I don't know if your professor showed this to you, but if you run a set like 5 times, you're gonna see 5 different things. Like let's say your set equals to 1, 2, 3. If you print the elements of a set, the orders are gonna be different. Once you're gonna see 3 to 1, once you're gonna see 1, 2, 3. Because Python just doesn't save the order to save the storage, you can't, like, it's meaningless to just call the element of a set because there's just no order in the set. So the question that I had, one of them was the FizzBuzz question. Can you see my Wing screen, by the way?
Yeah, we can see it.
Okay. So I kind of put these questions in functions so I can just show you one at a time. So one of them was the FizzBuzz question. So I'm going from, so my first step was that just why did I pick a for loop? The question says you need to run 100 times. So I clearly know how many times I need to run my program. It says 100 times. And I don't have a collection to work with. Like I don't have a list or anything. So my only option is to just use a for loop that has a range. And the reason I go from 1 to 101 is because the way range works is that it starts from the first element and it goes to the final element, but to the one before it. So this one goes from 1 to 100 exactly. If I had put 100, this would go from 1 to 99. If I had just left it as 100, this would go from 0 to 99. So the way range works is that it has 3 arguments: start, end, step. And these are optional. You can only type end. If you only type end, this goes from 0 to e minus 1. If you type, how's this? If you just type in s to end, this goes from s to e minus 1. And this is like an optional thing. I don't know if they showed it to you, but if you do like a step, then this goes from s to e minus a step, but it only goes like based on that step. So let's say this is 2. That means it goes from s to s plus 2, s plus 4, s plus 6, all the way to e minus 2. So this is how the step kind of thing works. If you don't know this, you don't have to know this. This is just an extra thing. But anyways, the way I did, I'm just going to comment this out. The way I did the FizzBuzz program was that, so I'm checking every single number from 1 to 100. And then I check if it's divisible by 15, I have to print FizzBuzz. If it's divisible by 5, I have to print Fizz. And if it's divisible by 3, I have to print Buzz. And if it's neither, I just print the number. And as said the order of the if and elifs matter. So the reason I picked if and elif system is because I only want one of them. I don't want because if a number, let's say your number is 15, 15 is divisible by 15, by 5, and by 3. I don't want it to print fizz, buzz, fizz, and buzz. I want it to just print fizz, buzz. So that's why the if and elif system was used. And another thing is that the order of these things definitely matter. Let's say I was like, if it's divisible by 5 first, and then if it's divisible by 15 next. This is wrong. Why? Because 15 is divisible by 5 too. So it just reads if it's divisible by 5, print fizzbuzz, it prints fizzbuzz and just moves on to the next number. But that's not complete. So when you have these types of questions, you want to have your most exclusive if statements on top. So the one that has everything, you want that one on top. And then the more you go down, it gets broader. So 15 is the special one, right? Because it's divisible by 5 and 3. So if it moves on from this one, that means it's not divisible by 15. That means it's either divisible by 5 or divisible by 3. It can't be divisible by both. We already checked that. So then it checks for 5. And if it's not divisible by 5, then it's either divisible by 3 or it's just divisible by neither. So that's what I mean by getting broader when you go down. So, and you can also check to see if this program works. And this is the type of output you were looking at. So start from 1, 3 is a buzz, 5 is a fizz, and then like 15 is a fizz buzz. Then it just does that. Again, 30 is a fizz buzz. The next example that I had was kind of the harder version of this example. I don't know if you saw it, but it's printing fizzbuzz, but only using one printf statement. And what that means is that because right now this is the typical solution, it has 4 printf statements. This is kind of the hard version, and I decided to use strings because then if you notice, fizzbuzz is created using fizz and buzz. So the method that I chose was that if it's divisible by 5, I just add fizz to my string. If it's divisible by 3, I add buzz to my string. Now, notice how I didn't use elifs here, because then I'm okay with the case that both of these if statements are run, because then let's say the number is 15. This one is run and this one is run. So then I add fizz and buzz together and I end up with having fizz buzz, which is fine, which is exactly what we wanted. And then if it's neither, if it's divisible by neither, I just set the string to the number. And this is not good practice. This is just, I wanted to show you that like you can just do it with one printf statement. But in a good practice, you don't want to set your string variable to a number variable, even though Python allows it. But yeah, if it's divisible by neither, I just set it to the actual number. And you can see that this program will also give you same output. Same thing, 15 is fizzbuzz, 3. So it's the same thing. Now, I noticed that some of you were trying to solve the prime number, right? Do you have any questions about the fizzbuzz one? Can I move to the prime number one?
One thing I want to mention about fizzbuzz is that I've definitely seen this question on multiple interviews. I think 2 interviews I've seen this exact question. So, keep it in the back of your mind. These processes will be useful. Question.
Yeah, it was. I mean, back when I did this course, it was actually it was in one of my labs, this question too. So it's definitely something that has been used a lot. So prime numbers. So before we even start, do you know what a prime number is? For prime numbers, did you use a while loop? I did it using for loops. You can also do it using do it using while loops. Yeah, 2 factors by itself. The reason I used for loops was because just like the other program, the range is still known to me. Because if you have a number like n, you know that you have to check the numbers from 1 to n maximum. But that's the range you're dealing with. A number can't be divisible by a number that's bigger than itself, right? So you still have a known range. It's a sneaky one because it doesn't explicitly tell you that's the number you have to deal with. But then if you just look at the definition of the prime numbers, you know that you have to deal with numbers from 1 to n. Just like the 1 and 100 scenario, I still have to check for numbers from 1 to n. But in this case, I have to do n plus 1, right? Because if I just do 1 to n itself wouldn't be included, and then we won't get the number that we want. I go through this range. This is really similar to the divisor question that you did in your labs. So I check to see if the numbers are divisible, and I have this counter. And if the number is divisible, I just add 1 to my counter, and then at the end of the program, I check if my counter is 2, that means the number was divisible. Why? Because then that means only 2 numbers were divisible, and those would be 1 and n itself. And if the counter is anything but 2, then that number is not prime, and I will just return false. Now, I didn't include this, but if you want this program to run faster, if you just think about this problem a little bit more, you'll see that you're checking a whole lot more than we actually need to check. Like, let's say our number is 9. So if I write down all the numbers from 1 to 9, you'll see that right around here is where we just need to stop checking. Because look, 9 is divisible by 1, 9 is not divisible by 2, and 9 is not divisible by 3. And after 4, oh, sorry. Yeah, did I say no? 9 is divisible by 3. And after 4, 9 is not divisible by 4, 5, 6, 7, 8, and all the way to 9. So 9 is, and so it only is divisible by 9, 3, and 1. So the thing is, when you're checking your numbers from 1 to n, from a square root of n above, you don't need to check it anymore. Because 3 is the square root of 9. So if 9 is divisible by 3, that means I can have a pair that's 3 times 3, and I can have a pair that's 1 times to 9. And just using these two pairs, I've already got all of my possible divisors. So another method would just be checking it from, instead of going from 1 to n plus 1, I can go from 1 to a square root of n, and I only need one divisor. If I get 2 or above, then my number is not prime. And the example of that is 9, for example. 9 has 2 because it's divisible by 1 and it's divisible by 3. So I already know that I have another pair other than 1 and 9. Because if I get the 1, I already got the pair that makes it prime. And if it's divisible by anything else in that range, that means I've got another pair. Like, let's say the number was 6. Here are my pairs. I have 1 and 6, and I have 2 and 3. So if I only check it up to 2, which is roughly square root of 6, I see that I have 2 pairs. That means my number is not prime. So that's like a faster way of doing it. You don't have to do it. Efficiency is not marked in this exam, so this is just the way if you want it to be faster. Now, the other part of this problem is really similar to the FISBOS problem, because now I'm like, you have is prime function, use that function to print all of the prime numbers. So this is the exact same situation as FISBOS. I'm still checking numbers from 1 to 100, except now my conditions change. Instead of doing it like divisible by 15, I run my prime function, and if my number is prime, I will just print that number. And you can see that that program works. This will just print the prime numbers from 1 to 100. And the final question that I had in my worksheet is very similar to some of the ones that Pranath had. It's just simple conditions. So I'm introducing this function called ECOR. I don't know if any of you have heard of ECOR, but it's basically, it will return true if only one of its inputs is true, not both. So when you have these types of questions that like tell you if the inputs are a certain way, just write it down. Like you can just write it down on a piece of paper. If A is just all the possible conditions that will return true. And chances are you can just convert that condition directly to an actual if statement. So the question says if A is true or only B is true, then you should return true. And that's what I wrote. If A is true and B is false, or A is false and B is true, that's when you have to return true. And otherwise, you return false. And if you remember from your labs, this can be refactored. because each one of these comparisons will give you true and false themselves too. Like if this one passes, it will give you true. If this one passes, it will give you true. And then true and true will also give you true. And then again, if this one passes, will give you true, true, true and true, true. And then the or itself will also give you true. So because these are booleans and we're also returning a boolean value, it's kind of redundant to have an if statement and a return statement saying the same thing. So instead, I can just return the value directly because these comparisons are all have an actual boolean value. So I can just say this and this will match the conditions. But the moment that you have anything other than a boolean value in your inputs, you can't do this. Like let's say your return values were integers, or like let's say you wanted to return the bigger one or things like that, you can't refactor that because the comparisons will just give you true and false. They won't give you the actual values. So this is kind of all I had to say about for loops and while loops. I know it's a tricky subject, so I can answer any questions if you guys have. Sure, I can go over the prime one. Do you still want the refactored one? Someone asked for the refactored one.
Like if you were to do the while loop version, but if you could do it with a while loop, I mean, find the prime number, but using a while loop instead of a for loop.
Sure. So you want? Okay, I'm just gonna write another is prime function. Sure. We'll call it is prime while. So let's say I want to have it go from. I want to have it in a while loop. So the moment you're dealing with a while loop, you're gonna need a counter or a condition. So because this one doesn't have a specific condition to begin with, we have to make our own condition. And I'm gonna use a counter for that. So you see how we have an I here? It's a good idea to make our own I too. So I'm gonna create a variable called I and set it to 1. And this is where the condition comes in. I'm just gonna say while I is less than or equal to 100. Now, do you see how this becomes a condition? That means that whatever I write after will keep running until that condition is met. And we still need our counter to see if you're counting enough divisors or not. Oh, by the way, I have 100. Oh, let's keep it as n plus 1. Sorry. This is like if you can see these are really similar because I'm going from 1 to n plus 1, and here I'm still going from 1 to n, except I can write this two ways. I can write it from less than n plus 1, or this is the easier way to it's visual to just say less than or equal to n because that's what you do in real life. And then the rest of the program, I don't need to change it. And for the rest of the program, I check to see if that number is divisible by I. If it's divisible by y, I add 1 to my counter. And of course, I need to increase I itself too, right? So I go I equals I plus 1. So the rest of the program is the same. My counter is still going from 1 to n. That was the number that I had. For each specific I value, I check to see if it's divisible by that value. If it is, I add 1 to my counter. Then I increase my I value to make sure this is going through that loop. And then outside my function, I check it. So instead of is prime, let's call is prime while this time, because that was our new function. And as you can see, it still prints the same prime numbers. I just wanted to show you something. What if I didn't have this line? Because I noticed in your lab, some of you had infinite loops, and I just want to say what an infinite loop is. So if I don't have that, I'm just going to show you what happens to the output. Nothing is printed. And the program isn't done executing, because when it's done executing, the little like bigger than signs come here. That means that this is still loading and nothing is happening. So I can't do anything. I have to essentially kill this program because this is not working. So yeah. Oh, okay. Yeah. I was looking for a stop button. It just doesn't have one. So So this is what happened. I'm just going to show you why that happened, why that program kept running. Because so it has I equals 1, and it goes, well, is 1 less than n? Yeah, 1 is less than n. So it keeps running, checks again, is 1 less than n? Yeah, keeps running. Is 1 less than n? And it keeps doing that. It keeps seeing, oh, 1 is less than n, 1 is less than n, 1 is less than n. And because you're not changing I, and I is still a state, I is still 1, it keeps doing that. It keeps doing that check, and it creates what we call infinite loop. But when I do that, I'm actually changing that actual I value. So now that doesn't happen. So it goes, is 1 less than n, is 2 less than n, is 3 less than n, is 4 less than n. And then depending on our n value, it will just stop. And now you can see our program is happy again. So yeah, and then you can tell that it finished executing because these little signs are back now. So it's back to being a shell. Yes, I plus 1 is necessary for while loops. Yeah, that's exact. That's because if you remove it, you'll get an infinite loop. Yep. So that was all for me. If you don't have any other questions, I'm going to pass it on to Matt to go over some of the lab examples. And I think the lab examples that Matt is going to go over are still while and for loops. And then Milan can end it with lists and tuples and sets, if that's right.
Well, we'll see which of the other TAs are left here on the call. So we got Matt and David, and they will be covering a lot of the some of the material.
Yeah.
Barty, could you show the example again? Or if you could just copy paste it into the Google Docs, and we'll make the Google Doc like fully public to everyone after.
Sure. I could just post it in the Discord server if everyone is in Discord, because I have the actual file.
Oh yeah, that's good too. But save it as a text file, because a lot of these people are having trouble opening .py files.
Oh, okay, sure.
Yeah. There are some other suggestions in the chat that I'm looking at right now. Let's see the chat on the. I can put the chat on the screen. Oh, never mind. It's not showing because.
Who?
Yeah. So afterwards, this will all be linked in the Discord. The recording to this. It's going to be a long video, but feel free to watch it on 2 or 3 times speed if it's too long for you. And if
I'm not sure what you mean by A and is that supposed to be A and B when you say A multiplied by B?
Yeah.
Because someone.
Okay, so and you want to use A and D, like the keyword A and D.
Yeah.
Some other programming languages might have multiplying for booleans, but Python is not cooperative with multiplying booleans. Just use A and D, the word and, instead.
But even if you just meant it as and, that will not work, because if you mean it as A and B and not of A and B, that will not give you the cases that you want, because for the case that they're both false, A and B would be false, and not of A and B will be true. So if you do not of false and false, the result will be true, but that's not what you want. In XOR, false XOR false will still be false. So yeah, XOR is actually an interesting function. You can't write it as a single and an or. So when you actually move on to further like logic courses, you'll find that XOR must be written as a combination of and or. You can't just write it as a singular function alone.
You don't want to do math between booleans. You want to use and or as words, not as plus or multiply.
That would still not work. Not of A or B will still not work.
But Doc Degan got it, so I think we're good.
Yeah.
So I think next on our menu for the plan for today was Matt was going to show off some examples from the labs. Matt, you there?
Yeah. I'm just going to go over 2 of the most requested examples right now because we're short on time. We've gone a long time, so I'm going to just go over. If you have extra questions you want me to help you with labs, just shoot me a DM on Discord or email and I'll help you out.
Okay.
All right.
One other
can you see the wing?
One other chat question. I do see your wing. But one chat question that I want to address first is someone asked, is it possible to call functions inside your for loop or inside your while loop? That is absolutely allowed. So you can call functions essentially anywhere. Inside a loop, outside a loop, inside a function. You can have a function that calls a function that calls a function that calls a function. Like you can have a chain of function calls that can go as deep as your computer memory will allow you to go. But of course, you don't want to do that if you don't have to. You only do that if it's necessary for the question that you're trying to solve. So yeah, feel free to call a function wherever. Now, Matt, could you zoom into your Wing code a little bit, just because it's on dark mode and it's a little bit small? I think you should be able to do control.
How do
scroll.
I do that?
If you scroll while holding control, you should be able to zoom in.
It's not doing anything. Here, probably like a setting. Does that do it? Nope. What if I just change it?
Go back to
Oh god, it's bright.
Okay, go to edit. I think I saw something that said zoom when you hit the edit on the top toolbar.
Oh, wow. Missed that. Alright, is that good?
Yeah. Okay, someone was asking if we can review the automatic and manual testing. I'm sure Matt will cover that because that is a part of some of these questions. Is that right, Matt?
Oh, sure.
some of the automatic testing, like test int.
Yeah, I'll go over that.
Awesome.
Alright, so I just took sum 1-3, which was exercise 5 of lab 10. It was pretty highly requested that we go over this. I changed it up a bit here, but we'll first go over how you should read a question like this. So let's start. So use the function design recipe to develop a function named sum13. So first, you're going to do the examples. That's step 1 of the function design recipe. So in this function, any 13 in the list is not counted. Any number that comes immediately after 13 is not counted. So I've actually changed this in my example to be any number that is 1 or following a 1 or preceding a 1. So anything before or after a 1 won't be counted. So empty list is going to give you 0. If you have this list here, 1, so this 1 is going to be ignored. This 5 is going to be ignored. 5 plus 10 plus 8 plus 7, 30. And then right here you have a 1. That 2 will be ignored. A 1 here preceding 2 will be ignored. And the 6 will be ignored, so that's going to be 0.
Matt, can you zoom in a little more?
So that's the examples. Yeah.
Just do Control plus, so you don't gotta click through the toolbar.
Okay. Is that better?
I think that should be good for the zoom depth.
All right.
We should get some feedback in the chat. The chat says good, so yeah, I think we're good.
All right, so reading the question. We'll just quickly read the question, highlight the important parts, then we'll get to the code. So it takes a list of integers. That's important. That tells you need to have list right there in the header because it takes a list of integers, which may be empty. That's important for your description because when you're describing the function, you want to say what it can take. If it can take an empty list, you want to make sure you specify that. Now, the function returns the sum of numbers in the list. So a float is a good return for a sum just because it doesn't say it has to be integers. So in case the inputs are floats, returning float is a safe value to return. And then returning 0 for an empty list. So you know that if the list is 0, you want to return 0, like if it's got no values. So the number 13 is very unlucky. So any 13 in the list is not counted. So make sure you remember that as one of the cases. And any number that comes immediately after 13 is not counted. And then it just is going to finish with examples. Make sure you test these examples because they give you the values it should be. So it's a very good way to test your function. If they give you something like this with the return, test it. So yeah, so here's the code. So we start the header. List to return a float, nums. This could be any name you want, really. Nums is just easy for sum because you shouldn't use sum since sum is one of the names as Millen went over at the start. So first condition, you're going to want to go over each condition. The first condition, well, you can, but You're not supposed to. Yeah, that's what I said. Oh, frig, it's right here. Whoops, forgot to change that. Don't know why that's not changed. But yeah, okay, so if the length of nums is 0, return 0. That's the case from the document there. It said return 0 if the list is empty, so that's the first condition. Now, thinking of how the function works, there's one other condition where it's not going to work the same as the other ones, and that's if the length is 1. Because if the length is 1, there's only going to be one value, so there's no looking before or after the function. So if nums0 is 1, you're just going to return 0, because then you have a 1, the 1 is not counted, return 0. Otherwise, you're just going to return that element. So if it's a 2, you're going to return 2. If it's a 3, you're going to return 3, whatever. And then you have the main case here. So to start out this main case, you can't just do, well, I'm going to change the sum to total, because you shouldn't use sum as a variable. So if we just change all of the sums to total, then that will work better. Okay, so basically, sum starts from 0 if the first or second value is 1. So if the first or second value is 1, your sum is going to start at 0, because if the second value is 1, preceding it is going to be 0. If the first value is 1, it's going to be 0, because 1 is skipped. So if the first value is 1, or the second value is 1, the first value is 0. Now, in the lab case, this case isn't there. It's just if the first value is 1. But since in this case I changed, we take the preceding value into account, it's going to be 0 if the preceding is 1. If the second value is 1, the preceding is 0. So otherwise, you'll start with the numbers. So in this case, you'll start with 3 because the 1 is the third value, not the second value. So this will get canceled, this will get canceled, the 3 is still there. And then this is where you have your loop. So since we know the length of the loop, we're going to use a for loop here, because we know it has to go until the length of the numbers. Now, this is where you have to be careful here, because you cannot index past the end of the loop. So you have to do a -1 on the length of the list, because you don't want to do the last index, because if you add +1 to the last index, that is when you're going to go outside the list, and that's going to give you an error. So because we have to do I +1 to get the next value, because we have to skip the next value. If the next value is 1, we want to put it to 0, because the preceding value, as the example says. So since that I +1 is there, you need to have length -1, and then you'll have to take into account the last variable in a separate part. So the loop can only go until the second last value. So for I in the range from 1, because we already covered 0 up here, so we start at 1 until that second last index. We're going to have if that value is 1, because if the value is 1, it's 0. If the number before it is 1, you're going to skip it, because that is one of the cases. And then if the number after it is 1, you're also going to make it 0. So in the case of the lab, it was only the one after that you were skipped. So you would only have this nums -1. So actually in the actual lab, you wouldn't need this -1 here, because you don't have the +1. Since we are also getting rid of the preceding value, we now have to have this I +1, because that checks if the next value is 1, because that will make the current value 0. So if the next value is 1, it's 0. If the previous value is 1, it's 0. Or if the value is 1, it's 0. So yes. And then add that to the total. So if this does not equal 1, if this does not equal 1, if this does not equal 1, all the ands there, add it to the total. If not, it's just 0, so you don't have to add it to the sum, because it's just 0. So then the case of the last number is going to be the last case we have to cover. So -1 inside a list is going to bring you to the last index. You could also do len nums -1. It's the same thing. Does not equal 1, and nums -2, so it's the same as len nums -2. This is to check the preceding value not being a 1. And then, yes, so the total is plus equals nums1 if those cases aren't true, and then you can just return the total. And yes, so any questions about that sum? All right, I don't see anything immediately, so. All right, I will just go on to the next one. If you have questions, add them in and I will answer them afterwards because I am short on time, so I have to get through this. All right, so I took sum 6, 7, which was, I believe, example. Yeah, I'm not actually sure what example it was. Yeah, example 6, lab 10. So I changed it to 2, 8 just because I don't want to show you guys exact solutions to the lab. So this is the same function except it's between 2 and 8 instead of 6 and 7. So we start with our header. We take a list. We go to a float, just like the previous question. Returns the sum of the values in the list, excluding sequences of integers starting with 2 and ending with 8. And then this is our special condition. Make sure you include any special conditions in the description, because this docstring, basically, when someone looks at your function, they're going to look here to find out what it does, because they might not know what all this does. But the docstring is going to explain what the function does. So you want to make sure you have those special cases. Return 0 if the list is empty. Then we have our examples, which you should write before the function, but then put them in your docstring after the description. So then we're going to start here. So start by initializing the total, sum variable, and the counter. So you always want to start by initializing stuff. Up here, we had to use an if to initialize because of the cases, but right here, we don't have to do that because all cases are going to be the same. Total is always going to start at 0, and the index is always going to be 0. So I chose to use a while loop here just from this solution. You could use a for loop and use, as I showed here, you can use true and false booleans, but just in this solution, I used a while because I used index instead of the known conditions. So yeah. So we'll start out going through the while loop here. So while I is less than len of nums, this is just going to go through your list as long as you're doing I plus equals 1 in the list. If you don't, you need to make sure you have this I plus equals 1 at the end, or you're going to have an infinite loop. But as long as you have I plus equals 1 at the end, this is going to go through all of the indexes in the list. So if the value is a 2, which in the case of the lab would be a 6, move ahead until we find an 8. So if nums I, which will grab the current index from the loop, is equal to 2, we are going to add 1 to the index. Now, this is a special thing with the while loop. If you add 1 to the index, it's going to go on to the next thing. So it's basically just going to the next loop. So by adding plus 1, we are going from this 2 to this 99, or from this 2 to this 1. So now we are at the 99. So we're going to have another while loop in here. Now this is because we want to go from 2 until 8. So because we don't know where the 8 is, we have to go until we find that 8. So while it is not 8, we're just going to keep going through indexes. So that's I plus equals 1. So here we're going to go 99. It's going to add 1, 99, add 1, 8. So once we get to that 8, it's going to stop. That's when it'll stop the loop. It will go right to the end here. I plus equals 1. So now the I will be after the 8. But since it's a while loop, that means it's now going to stop and go on to the return. So basically, it finds 2 right here. It adds 1 to the next index, goes to the 1. And then while it's not 8, it's just going to keep going to the next number. So then it hits 8. It's going to add 1. This add 1 is important because you have to go on to the next thing. Like, basically, once it hits 8, you need to have this add 1 at the end of the loop because then it goes to the next. And then this else right here is going to add to the sum. So else total is that. So if this, else that. So if it's not 2, it just goes to the sum. And that's pretty much it. So I actually wrote this alternate solution because I noticed a lot of people use this solution in the lab, and it's totally okay to use booleans here. So for item in list, so this kind of for loop where you just have in LST or in the list, item is just going to go through the list, all the items in the list. It will go 1, 1, 5, 5, 10, 7. So if the item is 2, you can set, actually I missed adding, you have to set skip equals false at the start as an initial condition there because you don't want to be skipping numbers when you first go into the loop. So if you hit a 2, you would set the boolean skip to true because that boolean being true will then make it so you can use an elif. So it's important that you have else if here because if item is 2, you don't want it to trigger anything else. So elif item is 8, So this will go if it's 8 and skip is true. So if it just hits an 8, then you don't want it to skip that because it's not 2 8. It's not the sequence 2 8. So you want to have that and skip equals true. So if skip is true and its item is 8, it's going to set skip to false and then go on to the next item in the list. And then else, so this is if it's not 2 and then it's not between. Actually, you know what? I did miss a case here. So it's actually elif skip is false. So you don't want skip is true there. I forgot to add that in. So elif skip is false. So if skip is true because it hit a 2, that means it's just going to keep, nothing's going to happen in this loop. This is not going to enter this. It's not going to enter this. It's not going to enter this. So it's going to keep going until it hits 8 and skip is true. And then it's going to set it to false. So then once skip is false, which is going to be at the start of the loop and anytime it's not between a 2 and an 8, then it's going to add total to the item. Then you can just return total up here. And I will return your total. So 29.5, that sort of thing. If you have any questions, please add them to Twitch and I will answer them. All right. So I believe Millen or David, I'm not sure who's going.
I think David, if you're still on the call. Oh, bro, Matt, you still there?
Yeah. Oh, testing.
Testing, man. This is important.
My bad. Yeah. Okay. I'm gonna have to grab some of that because I don't have it written down right now. But I'll just take a second.
Go into announcements. It should be.
No, I could just grab it from the lab. Lab 10. Okay. I got it. So, there we go. All right. All right, so I'm going to show you guys the loop automated testing just as an example because you could basically derive the manual. Oh, wait, Jeff, probably the function. Yeah, no, 1 sec. Let me just grab the function. Wait, it's going to. Okay. Okay. Sorry.
It's all good. Now, the reason why testing is important is because after you write your function, it is possible that you wrote it in a way that it doesn't do what you expect it to do. If your function does not do what you expect your function to do, that is certainly an issue. So the reason why we do testing is because we want to identify our problems with our function before we try to use it in any serious applications. Some job positions are actually completely dedicated to just testing other people's code. If you look around for QA or quality assurance positions, if this type of stuff really excites you, like thinking of test cases that can break code, that could be an interesting career move if that interests you at all.
Yeah. All right. I'm ready now.
Okay, you're live? Your screen's live?
Yeah. All right. So this is a test function that you would have seen in the Discord server, also which you would have made in, I believe, lab 7 or 6. I'm not sure which one it was, but basically it takes a string, expected, actual, and then I'm not sure why that's to list, but oh wait, yeah, it's because of the loop testing. But yeah, then your allows it probably would have been to int or to bool. I mean to int because it returns 1 or 0. But basically, the expected and actual, these values will be based on what function you're testing. So if you're testing a function with an int, expected would be int, actual would be int, or if you're testing a function with a boolean, it would be bool or bool. It doesn't really matter. You could technically use the same test function, but since we use type annotations because it's good practice, you should use a different test function for each kind of variable. So you print the description, which would just be whatever, testing bank statement, down here, or and then print expected result, actual result. That's just, you put expected. This will just print this value that you gave the function. It will print that value that you gave this function. This is just so when you're looking through the Python shell, you can easily see what it's being tested. So if something fails, you can see what failed. So then if expected equals actual, so if that value is equal to this value, then the test passed. Now, the expected value is just going to be a value that you hand calculated or that you're given that's expected. So if it's just a function that like adds 2 to x, it would just be, if x is 4, you'd go 6. And then actual, you would call that function with 2, and then it should equal that, so the function test passes. Otherwise, if they're not equal, the test failed. You're not getting the expected value. So you return 1 or you return 0. Now, these returns are just so you can do a counter. As you can see here, number of passed plus equals the function call. So since this function returns 1, if the expected equals the actual, then you're simply just going to add 1 to n passed, because that means your number of tests passed is up by 1. So this is an example of automatic testing with a loop. Now, you guys asked about manual testing. Manual testing is simply just a print statement that you can look at in the shell. So if you like print quote testing function x, then you could just have like expected equals, and then just code like put this into your function. Because this is manual testing, not automatic, you're just gonna hard put the number in. So you just do expected equals 4, and then comma. Oh wait, no, and then you could just add comma actual equals quote comma, and then you just call the function here. So function function x, and then so that's manual testing right there. It's pretty straightforward. The reason you use automatic testing is because if you had to do this manual testing over and over again, you'd have to be like print, wrong copy paste. But yeah, basically you would just have to print that over and over and over and over again. And that's just tedious, having to punch in expected over and over and over and over again. So that is why we simply use this loop right here. So what this loop does, I will explain to you. So tests and passed are going to start at 0, just like the functions up here. You want to always initialize 0. So then using loops, this is the special thing about loops. You can actually take lists of inputs and outputs. So this list here, this will be a first input, and then the first list inside this list is going to be the expected output. So this is your actual value, and then this is actually a second actual value. This is expected, and this is expected. So basically, instead of doing actual equals this, test the function expected equals this, you just skip all the actual equals expected equals into one statement, which is going to be a list of lists. Now, if this function was simply just floats, you would just simply have a list with floats, like list of 1, 2, 3, 4, 5. It's just whatever values you want to put into the function, and then these are your expected returns. So basically, what this does is for I in the range of the length of that input list you have. So it's going to go through the input list. It's going to add to n passed if the test function returns. Now, this is where it gets a bit complicated for using a loop, because this test function needs to have the index included in it, because that index is going to be basically changing every time you go through the list. So instead of before, where you would have just simply put printing function x inside these quotes, you're going to have to use from the list the string of that, because it changes every time you go through the loop what this is. So then bank out I, so because this is bank out, so the first time it goes through the loop, this will be put in as the expected value to the function. Then the second time it goes through the loop, it will be this as the expected. And the actual is simply just bank statement bank in I, so this will take the input here. The first time it will put this in, and the second time it will put this in. And then n tests plus equals 1 after every test, because you want that. So at the end, if you want the counters, you would simply just number of failed tests is going to be your number of passed tests total test, number of tests, minus the number of passed tests, because number of failed will be 0 if all the tests passed, because this will just equal 0. Otherwise, it will add for every passed test that doesn't exist. And then you just print those values. So is that a good explanation? How did I do the counting part? Can you be a bit more detailed of what you mean there? Hello. Do you mean the sum 1, 3 here, or the testing? Just in Twitch. How'd you do the counting part? Oh, yeah, okay. So basically, you have this number of tests passed variable that you start at 0. So then because your test function returns 1 every time a test is passed, you can simply do n passed plus equals the function, because this function will be 1 if the test passed. So it's the same thing as saying n passed plus equals 1. Then since it returns 0 if it fails, this will simply be 0. N passed plus equals 0. It won't add to n passed. So then you just want n tests plus equals 1 after every single function calls. Like every time it tests, you just want to add 1 to the total tests, and then you just get the failed by doing the number of tests minus the number of passed. Now, if you want to see, like, if you just ignore this loop and replace this with expected, and this with x, and this with bank in x, just to show regular testing. So there we go. So this would be just automated testing without a loop. You would just have n pass plus equals this, and then n test plus equals 1. So then it would take the expected value they would have to put here. So expected equals 5 or 4 or whatever. And then bank statement x. So if this equals this, that will give you a plus equals 1. And that will add 1 to n passed, 1 to n test. N failed will end up as 0 because 1 minus 1 is 0. Then you can simply just print tests passed and then n passed and then test failed and failed. So do we have an n in? You don't have to do a blank in and blank out for each example in the function docstring. You should say what it takes in, you should say it takes a list and puts out a float in the docstring, yes, because if somebody's reading this, but this is also covered in the header, so it's not as important, but just remember these docstrings, someone's looking at your code, they might not know, they don't necessarily know how Python works, they're just using your function. So this docstring is to show them exactly what your function is going to do. So you want to make sure you say what it wants. You want to make sure that you just cover all those bases. If it wants a list, you want to make sure that you specify that it wants you just want to make sure that that customer or whoever's looking at the function knows what the function does. All right. I will pass it off to Millen now. Wait, or D, I don't know.
You can pass off to Millen, who will pass it off to me.
All right, there we go.
We have a relay race. Another question in the chat is within the loop of the automated testing.
Within the loop, do you have to do an in and out for each example?
You do have to compare your actual returned out value, the return value of a particular list function. You have to compare that directly to what you would expect.
Yeah.
If that kind of is what your question is asking for. So your list is like, the zero element.
Oh,
the zero
okay, I
index
see what
in
you
both of the
mean.
lists is
Yeah.
going to be like, corresponding to the input and the output. The one element or the one index in both of the lists is going to correspond to the, the second input and the second output that you would expect when you're testing.
No, I see what so you mean the lists like in and out. Yes, we'll have to make a different input output list for every function because they're going to be different for every function. I mean, unless you're like testing two similar functions, you're going to need like a bank in, bank out for the bank statement function, like sum in, sum out for the sum 6, 7 function, just like that. Yeah. So you're just going to want a list. So instead of doing what you would have had to do before, we do like expected equals, expected equals, expected equals, expected equals. You just have a list of all those actual values and all those expected values. Well, not actual values. It's a list of all the inputs because then you put that input into the function to get your actual value. Technically, you actually could do it by calling the function inside the in loop, like in list, I mean. So like if you have the input list, you could call the function in that and not call it in the loop, but it's going to be the same outcome. So yeah, all right.
All right. Hold up. We got someone asking about converting strings into variables. Like JavaScript. Let's not worry about that. That is not necessarily relevant for the exam coming up next week. We got to focus on that for I don't know if Python does that or not, but like the stuff you do in JavaScript, like you don't got to worry about that for this exam. It's all right. Don't worry about it. It's all cool. So I think we can pass it on to David, who's going to cover some stuff about sets and tuples, which are kind of like lists, but not quite the same. We got to know the fundamental differences, and David will give us a nice presentation on sets and tuples and how they're similar and how they're different to lists. Sound good, David?
I'm hoping it's a nice presentation.
Well, you can show us how it's done.
Hopefully. So
could you zoom in a little bit to your code? Because your font's pretty small.
Oh yeah, for sure.
Control plus.
Yeah.
Okay, looks good.
Okay, perfect. Okay, so in this we're going to be covering lists, sets, and tuples, right? So the first step is to know the differences and when they should be used, right? Lists have order. They can change, which means they're mutable. That word's going to pop up again if you're in a software engineering or computer systems, or quite a few of them. Every single value has an index where it can be referenced by, and it can hold multiple of the same value. So a list can have one, and then it can also store another one, right? This is different than a set. Sets do not have order. Although they can change, and they do not have indices where they could be accessed. At the same time, you cannot have multiple of the same. So the key ones that you want to look for in sets, like the differences, are that they do not have order, and you cannot have multiple of the same. Then finally, you have the tuple, and it's basically a list that cannot change. So the question might be, when should we use each one of these? So, So personally, I rarely ever use tuples, right? But on the exam, you might be asked to use one. But for sets and lists, if you ever see the keyword unique, then you know you should probably be using a set. If you do not see the keyword unique, and you have to access the indices, then it's probably better to use a list. So let's just hop into it and start using them.
Wait, can I say something real fast?
For the first example, we're going to be...
I just have a very fun way that I like to use to help memorize some of the different properties about sets, lists, and tuples. So think about the first letter. A list starts with L. So does life, and life can change fast. So you got to know, and life has an order to it. That's how I remember it. Tuples, they start with T, just like tattoos. Tattoos, you can't change them once you make them, you can't change them. So that's how I remember tuples, tattoos. And sets, start with S, I think of them like soup. Like when you have a soup, you don't know the order at which your things are added in there. You just kind of have it. And I mean, adding salt and then keeping on adding salt is not necessarily going to have a large effect. So I use soup and sets to help me memorize things. Making little mnemonic devices like this could be helpful. But yeah,
that's a pretty good one.
Just a nice thing that I made up while staying up late at night. All right.
It's actually a really creative one. I'm not gonna lie.
Appreciate it.
We
got a question
so
on
someone
the chat.
So the question is it possible that the questions and their different solutions are provided for us for later use? Yeah, absolutely. So the questions are posted in the review. So I highly recommend you guys like join along and write it out. Or better yet, see if you can figure it all out before you even say it. That's the best way to learn, is just to figure it out yourself. Because if someone tells you, it's not going to stick. So here we go.
Tattoos for tuples and soups for set. Yeah, because soups, you don't know what the order is that things were added in. It's just in there or it's not in there. Tattoos, they don't change, just like tuples. They will never change. List for life, because life changes fast.
Sometimes it's just that simple.
Yeah.
So when doing this, I thought, okay, you guys have seen enough of using functions. So in this case, we're just going to be doing prints. They're just faster. But on an exam, I have a strong feeling that if they ask you to use a function and you don't, the TA that's marking you won't be too happy. Someone asked whose life is empty, and it's kind of tough.
All of us, but also none of us.
Yes. Okay, so
order matters.
Does
for
the
lists.
order of the...
Yes.
Okay.
So like,
yeah,
kind
so
of
order
like your life,
definitely
the order that things happen matters. Like you're not going to go into grade 5 before you go to grade 1. The order matters.
So I'm going to go with the examples. Each one is going to have a little bit of a story with it. I hope it makes it a bit more fun. And it's to give you guys an idea on how this might be useful and its practical applications. So currently I have a list, right? And so what the list stores is the TAs, right? Like their names. So you got David, Millen, Fernand, Bardia. I'm afraid Matt's not there. That's definitely my bad. So he's off the grid for now. So pretty much what it is it maps the index to their name. So if the index is going to be their employee number and the value is going to be their name. Okay. So the first question might be, if you're the prof, you might want to ask, okay, first of all, how many TAs do I even have, right? Because I'm sure you guys have looked at the Discord. There's quite a few. So let's figure this out. So it should be, there should be a function for us to figure it out. And luckily, the length function is here to save the day. If we want to figure out how many TAs there are, we go length, then our list. So one thing to know about the list is when you make it, it's going to be with the square brackets. And then every single entry is just going to have a comma between them. And the entries are going to go like this. First one is going to be 0, second one 1, third one 2, and so on. So this is definitely going to catch a lot of people off guard. And the reason why is if you want to get like how many entries, which in this case is 4, the fourth element is actually at the index 3. So it's kind of awkward, but it'll make sense. So if I want to get how many TAs, I'm going to print out. First thing about them is there are this many. And we could go TAs. Okay. So the length function is just going to get the length of the list. So let's test it. Sweet. There's 4 TAs, or at least in this list. Hopefully there's more, but okay. So the next question is, let's say you're a prof and you have a favorite student named Bill, right? And you want to make sure, okay, is Bill one of my TAs? Well, that's a really good question. Surely there should be a way to figure that out. So there is. So let's say we go here. Bill is a TA. So what we do is we make a new string. We call it Bill because that's what we're looking for. And we say Bill in my TAs. So what it's going to do is it's going to look for the entry Bill inside of all of the TAs. So we can check if that's the case. Bill is not a TA. So next question. So let's say we want to get the employee number, right? And this is where order kind of matters. So in this case, David's employee number is 0 because he starts off at the 0th element, right? Millen's is 1, Pranath's is 2, Barty is 3. Makes sense. So this is a way to map a number to a person using a list. Okay, so let's say we want to get Pranath's employee number. Well, let's think about it. What we want to do is we want to go through the list, entry for entry, and then check if each one has a name for Nath. Okay, that's not too bad. And if it does, then we want to print out their index. Okay, so because it uses index, that's a pretty good sign that we want to be using a either for in range loop or a while loop. So for this, I'm feeling like a while loop would be a fun way to do it. So what we want to do is we want to make a new variable. We're going to call it employee num. So first step is we want to set it to 0. Then we go, we're going to go while, and we get our TAs. So if we want to access so if we want to access the value of any entry inside of our list at any given index, we do this. We go our list, then a number. So the number we want to get to, employee num. So as long as it's not Pranath, then we'll just keep looping through and looking for another one. Okay? So what we do is we go to the next value. So what this is going to do is you set the employee number at 1, and then you say, okay, is this employee equal to Pranath? And if it's not, keep looping through until we find one that is. So that's perfect. Okay, so next, finally, we just want to print it out, saying is, and there we go. So Pranath's employee number is 2. And if we go back to the little Microsoft Paint, that's his index, which is his employee number. So it works. So that's a cool way that you could have it so that the index is actually pertinent information inside of your program. Okay. So next is, what's the name of the last employee, right? So let's scroll up. And so we look at our list and we say the last employee added was Bardia. And we want to make a program that finds this. Okay. What we want to do is we want to say the last employee added and then we go my TAs, because that's a list, -1. So it's kind of weird that we can have a -1 entry in here, right? Because it goes 0, 1, 2, 3. Okay. But here's a catch. Over here, 3, or the very last entry in your list, has an index of -1. This is something that Python has added just to make our lives easier, right? This will have one of -2, -3, and -4, right? So if I wanted to get, the fourth last, I could just go over here and say my TA is -4. But for this question, we just want to get the last employee. And -1 is just going to do a nice job on that. Sweet. So we know Barty is the last employee added. Okay. So finally, the last one for lists is, what is the name of the TA with employee number 2? So we want to go print the employee or the TA with the employee number 2 is, okay. So what we want to do is we want to access the index at 2. And we can already guess that's going to be Pranath. So we go over here and we say my TA is 2. So that's going to get the TA with the employee number of 2, and we run it. One thing to note is employee number 2 is actually the third employee added, because the first employee gets an employee number 0. So that's a way of using lists if you wanted to do a, what is it called? A little program just to keep track of your employees, how many there are. So this does have real world applications, and it's going to come in a lot of handy. I know this is a general engineering course, and one thing to note is there are a lot of programming jobs out there, and a lot of them are going to be inside of your field. A job posting I applied to was for an environmental engineering job, and that one required knowledge in Python. And almost the entire way through the interview, all I had to do was manipulate lists in Python. So knowing lists, sets, and tuples is good for all engineering disciplines. So it's definitely best to get this down. So I hope that gives a bit of insight into how lists work and how they might be useful. Because if you're manipulating data, the odds are it's going to be stored in a list or maybe any other data structure. So the next one is sets. So previously we touched on how sets do not have order. They're subject to change. And they don't have indices to access where what happens. And you can have multiple of the same value. Okay? So this kind of shines in this question, because what I might have here is a set of my favorite numbers. Don't worry, I don't have all these as my favorite numbers. You know, maybe 3 and 7 are the ones that stand out. But it's going to be a set. And the reason why this is a set is because if I added another 7, it doesn't make a lot of sense. So the other 7 is going to get canceled out by the 7 already in the set. So there's only going to be one of each number in the set, no matter what, even if I add it in. So the reason it makes sense, especially for keeping track of my favorite numbers, is because I can only have one of each number is my favorite number at most. I can't have 100 twice in this set. So that's a logic on why a set might be useful for this. So first question, really similar, and the question is, how many numbers are there? So if I want to know how many numbers are my favorite ones, all I have to do is say, here we go. I go the length function, and that's going to get the length of the set. And that's going to say, I'm going to get the length of how many numbers like I like. And then we say, are my faves. We run it. And it's a really good practice when writing is just go step by step to make sure that everything makes sense. So one thing to demonstrate is if I add another 7 onto the list, or onto the set, my bad, what's going to happen. So notice down here how it says 9 are my fave, so I have 9 numbers are my favorite. If I add another 7, in a list, this would give out 10, but the set keeps it is 9 because it only keeps one of each unique value. So I'll just add a little word here. Sweet. Okay. So the next question might be, what are the sum of all my favorite numbers? So you probably noticed by now that these data structures and loops are very, very useful together and not too useful alone. So our goal is to get the sum of all numbers. So we're going to start by assuming that the sum is going to be 0. But as previously mentioned, it's probably not a good idea to use the word sum. So we're going to write total nums. And we're going to start that off at 0. Then we're going to want to do a for loop. But we can't do it in range too well at all because they don't have indices like you would with a list. And even then, the indices are random, so you wouldn't even want to touch that. What you can do, however, is you could go for num in, let's see, what did I name it? My numbers. And what we do is we go total nums plus equals num. So we're going to add each number every single time, and that's going to give us a sum. By the time it's done the loop, we've summed up every single number in the list. So finally, what we can do is we can go print. We could say the average number is, and this is like the sum of the numbers, my bad. So we're going to say the sum of the numbers is going to be total nums. We could check it. And there we go. So the sum is 594.1. So this would have been very tedious, even just to type into a calculator. But just using Python, it's already done. All you have to do is loop through it. Another option that may or may not be allowed on the exam, so you definitely want to be scared to use it, is using the sum. And in that, you could just go sum my, and that will sum them up for you. But we're definitely going to be scared to use it. And this is small enough anyway that you shouldn't worry about it. Just a pro tip down the line. So the next is, what is the mean number? When dealing with this, a big field that's blowing up right now is data science. So if you want a good job in the future that deals with Python programming, it could be worth going into data science. And a lot of what data science is statistics. So let's say I want to get the mean of all these numbers in my set. Well, we've already got the total nums. And because this isn't in a function, or if it it'd probably be in the same function. I'm just going to reuse the variable if that's okay with everyone. So what I want to do is I want to go print, and I go total nums divided by length of and we're just going to say this is the mean. So notice how with this, there's a bit of, well, if we had to redo this loop, it'd be a bit of copying and pasting. And that's not too enjoyable at all. And that's why we might want to use a function. But luckily, because they're in the same scope, we could have just reused the variable. So when we run it, let's figure out what the mean is. Oh, well, that's a problem. So what do we have here? Print total nums. My nums is not defined. Because it's my numbers. My bad. Now we run it again. And we have the nice number 66 with quite a few decimal places after. So, finally, a good question might be, is 7 even one of my favorite numbers, right? So this is doing a search inside of your set. And this is going to come up a lot, like throughout your programming career, knowing whether or not something is even in your collection. So this could come up. An example would be, let's say I'm the prof again, and I decide, okay, I want to know if this person is in the class, right? I can check if they're in the class, and if the class is a set, well, you're pretty much doing the exact same problem. So what I want to do is I want to say 7 is fave number, and all I got to do is it's exactly the same as the list. Python makes it pretty easy for everyone to reuse like concepts. So what we want to do is we want to go 7 and my numbers. If we run it, is 7 in my numbers? True. If we look up here, it is. So that's how you use sets. Finally, we're going to do tuples. So tuples are immutable, so we're not even going to try changing them. And in previous examples, we didn't change lists or sets or anything. But let's look at let's look at tuples in specific. So tuples, to make them, you're going to be using the parentheses. So right now, I have a list of beings. So this is just things that are alive and their favorite languages. So we look. So my favorite language happens to be English. Who would have guessed? It's actually my first language. A little bit of David trivia out there. So Millen, well, his favorite is C. I don't know why he would pick English. I don't know if this is true. I just made this up.
I do like C.
You might be the only one.
Oh, I guess I'm the only one that sees the beauty in C. You see?
Oh my! do you have like the soundboard with you? I'm sure there's a cool note you can play. I'm hoping.
No, I don't have anything that corresponds to a C. Well, I don't see anything. Not in my current soundboard sequence.
Got him.
But we can carry on.
Okay. So definitely I should have warned him about that beforehand. Then we have Bill. So we remember Bill as being the prof's favorite person. And Bill's favorite is C++. Pranath, well, he's a Python TA, so I thought I'd give him Python as his favorite language. Hopefully I'm not too far off. Bardia, same thing, Python. And then my dog, Charlie. His favorite language is barking. And I'm surprised you guys haven't heard any of that yet. So, the first question might be, how many beings do I have? Well, this is an interesting question because we don't want to count how many entries or inside of like every single tuple because we don't want to count David and English as a being. We just want to count each tuple as a being. Okay? So, here we go. We go print and we're going to say there are this many beings. Honestly, it started off as people, but I just had to add my dog there. So we're going to go the length of my beings. Sweet. There's 6 beings. Okay. So luckily, it's just going to look at how many tuples are inside the set. One thing I did forget to touch on, which I regret, is that inside beings, it's a set, and I didn't touch on how to make a set. So to make a set, all you really have to do is use curly braces, and it's just going to do that for you. So there we go. That's how many beings are inside my set. Now, does anyone like English? So it happens to be me. So I would definitely say yes. So we're going to say print, does anyone like English? And my answer is, well, it's going to be a bit weird, right? Because we can't just use the in, because what we're looking for is English inside of a tuple inside of the set. Ooh, that's going to be annoying. And on top of that, who knows? Maybe someone named their being English, and that's a weird name, but you know, it's definitely a possibility. So what we have to do is we want to check the second entry of every single tuple, or at least enough tuples, and check, okay, is the name equal to English, or is the language equal to English? Okay, so you may have guessed it. Yes, sir, it's going to be a for loop. So what we want to do is we want to make a Boolean, and we're going to say likes English, and we're going to start off as false. We haven't looked yet, so we're going to assume that no one likes English, and our goal is to prove that wrong inside the for loop. So we're going to say for, let's say being, in beings. Okay, so we're going to go through each being, and we're going to want to check if being, now we look over here and we say entry 0 is going to be the name, and entry 1 is going to be what language they like the most. So because we're going to check the language that they like the most, we're going to say if being 1 is equal to, and we're going to say English. One thing I definitely would like to note is I'm not using constants right now. And that's just because I'm a bad programmer, plain and simple. If you want to make this a bit better, what you could do is you could say, make a constant language and set that equal to English. And do language here. So I'm sure what some of you guys are wondering, okay, why would we use a constant when it does the exact same thing? Later down the line, what might end up happening when you start coding is you get these a bunch of literals. Like maybe you have like 9 scattered throughout your code, and you might not even know what 9 means. 9 could be how many kilometers an hour something is, or it could be how many rotations something has, or how many rotations it should have. So it's a way of grouping things up, and perhaps down the line you might want to change your 9 to a 10. Instead of having to do Control F and replace all of them, having a constant just makes life a little bit easier. So wherever you can, it might be worth making a constant. On this example, 1 could also be a constant, but I'm gonna say no. I'm just gonna be a bit lazy here, which is definitely not the approach you want to do. So my bad. So if we know that any being has their language equal to English, okay? Well, that's a key thing that at least someone likes English, right? And I'm not talking about the class because I don't think anyone likes that class, but I could be wrong. So, likes English turns true. Sweet. Now we go back over to our print statement, which is down here, and we throw in the Boolean. Say likes English, and there we go. So someone does like English. So something that you may or may not have been taught. If you're very comfortable with for loops, one very interesting thing is you may have noticed this is a bit inefficient. The first entry likes English, so we know that at least someone likes English. But for some odd reason, we still check every single other entry. There's a way that you could do using a break. And what the break does is it says, okay, if someone likes English, stop the for loop and continue the program. If you guys have no interest in using this or find it a bit complicated, this is just something to help with the efficiency. So I'll write that down. Perfect. So now we know at least someone likes English in our data set. So next thing we want to do is check Bardia's favorite language. So let's think here. Okay, well, we can't really use the in again, and we know that we can't use an in range really well because this is a set. Okay, yeah, I don't think breaks or continues are allowed. So I wouldn't know. I haven't looked at the exam rules. But if they're not allowed, I'll just exclude it. It's just something that's cool. I'm a big fan of using breaks, and down the line, I'm sure most of you guys will be too. They make life a bit easier and make the program a bit more efficient sometimes. When used right, of course. So, we want to find out what Bardia's favorite language is. Yeah, I think I think the whole FBI unit's going to bust down my door, to be honest. So definitely don't tip them off. I'm not trying to have a swatting stream right now. So, okay. We want to figure out what Bardia's favorite language is. And, well, we already know it's Python, but a lot of the times you won't actually have a clue. You won't have it set up for you. But let's try again. So what we want to do is it's going to be really similar. In fact, in this case, it's bad practice to copy and paste. So don't tell the FBI this as well. But I might just do it. So we're going to say for beings and beings. This is the part that's interesting, okay? We're going to loop through all of the beings. And we want to say if their name, and we're going to say being 0 is equal to Bardia. Oop. Now we want to get their name. Well, it's perfect for us to add a variable right above it. So what we're going to do is we're going to say, here we go, Bardia's lang, and that's going to be for language, and we're just going to assume it's nothing. Until we know, there's no point of assuming. So we're going to say if being 0, so if we scroll back up, the first entry is the name. And the second entry is going to be the language that they like. So we want to say being 1 is going to be Bardia's language. So we're going to say Bardia lang. Sweet. So now we can get Bardia's language. The last part is we just want to print it. Okay. So we're going to say, so Bardia's favorite language, and that's going to be Bardia's lang. So I'm sure you guys could guess. In this case, it might be Python. It's pretty suitable because he's a Python TA, but it could be anything else. Who knows? So finally, we know that dogs love to bark. Oh yeah. So in this specific example, if we look at the tuple, we have a name that comes first, and then the language that comes second. And this is exactly like how lists work, right? So if the first entry, like you type in, is going to have the value 0, and the second value is going to have 1. So this is just something for this example. One good practice when doing data science is just to make sure you get like a strong understanding of what type of data you're using. So I definitely should have included that inside of the comment. Thank you guys for checking. Okay, so we know that dogs love to bark. luckily for everyone, my dog doesn't love to bark right now. Thank goodness, because he's a small dog, but trust me, his bark is pretty loud. So we know that their favorite language happens to be barking. What is the name of the dog in the set? That's a fair question, right? So we want to look through the set and check if anyone enjoys barking. Okay? And if they do, then we want to return their name. So we're going to go, let's see. First, we're going to set up a variable of what we want. We want to say, okay, we want to get the name of the dog, right? So we're going to say dog name, and we don't know the dog's name. We're not going to take assumptions. Okay, so next, in this scenario, we want to do a for loop because we can't just use an in. That's not going to be very practical for us. So we're going to say for. We're going to say for, let's say, being, exactly how we did it in beings. Okay, sweet. So now we're looping through all of the beings, and we want to check if any of them enjoy barking. It's pretty safe to assume humans don't enjoy barking, but the rapper DMX does, so I can't say that for sure. But for this data set, it's a good assumption. So we're going to say if being 1 is barking. So if the language that they like to speak is barking, we know that they're a dog. And the best way to deal with that is saying your dog name to your being name. Perfect. And this is going to go all the way through. Finally, all we want to do is we want to print, we're going to say dog name is the dog in the set. Now we run it, and first it's always nice to check, okay, how do I know this even works in the first place? So we go over to the data set and we say, okay, Charlie enjoys barking. No one else enjoys barking. Okay. We go down, bam, we say Charlie is the dog in the set. So you can see how using lists and sets allow us to process data, especially efficiently in Python. You can use an Excel sheet for an example, but with Excel sheets, it might be annoying. Plus, you have to learn Excel. Luckily for everyone, you're learning Python, and so you've already learned it. You could use it to process data, and it's pretty easy, as you can see. In only a few lines, we were able to print out who was the dog in the set, and that was pretty convenient. So we got a cool new one. This is a bonus one. And the reason why it's a bonus one is because this was a question I got in a job interview. And I ended up getting the job. So I definitely think this is a good solution. Okay? So let's paint the picture on the context of what's being asked. So let's say I'm monitoring a screen. Okay? And there's a bunch of colors on the screen, but I want to know what colors are on the screen. I don't care how often they're on the screen, I just want to know. For an example, I might have a camera looking at a patch of dirt, and the camera's going to be like, okay, I want to look for green, and that's how I know that my plant is growing. So I don't care how much green, I just want to know, okay, is there green or is there not green, okay? So that's kind of like the context, and I just want to get a list of unique colors. That's it. So as you can see, let's first look at colors. We have green, red, blue, pink, blue, red. Oh, that's weird. We've already seen blue and red. Well, that kind of sucks, because if we look over here to the list and we scroll up, we notice that lists have order. Okay, I don't care about order, but apparently the user does. They can change. Well, okay, that's a nice thing to have. They have indices, that's cool. Multiple. But they can have multiple, apparently, or multiple for the rest of us, of this same value, which sucks because we only want one of each unique value. So it's kind of awkward because now we have a list where we have one of each or a list, and we want to get one of each value. So what are some approaches that we could take to do this? So one approach involves loops, and you loop through it, and you just ensure whenever you add something to a list, the value that's there hasn't been there previously. Well, it's not that elegant. And to be honest, it's not that enjoyable to write either. I've done it. So, what's another approach that we could do to make sure that every single thing in our list is unique? Well, we know that sets, although they don't have order, right? And they don't have indices, they cannot have multiples of the same value. So every single value in exactly, we turn it into a set. So let's see how we walk through it. So let's start by printing a set of unique colors. So we're going to say okay. Oh, that's no good. Okay, so now we want to print a set of all of our colors, and well, a lot of the times it's just good to see if it works. So one step at a time. Okay, we go over it. I think it's a bit small for you guys to see, and I wish I could make it bigger. But we have green, red, blue, pink, blue again. Because it just printed out colors, so it's a good thing I checked. So what we want to do is we turn it into a set just like this. This may have been taught, maybe it hasn't. But down the line, this was an interview question asked of me. And so either way, if it hasn't been taught, feel free to ignore it. But if it has, it might pop up on the exam. But even if it has not been taught, it might be something good to know. Because who knows, maybe you'll apply for the same position I have. And, the second you go over to the interview, I hope they ask a question and you think, oh my goodness, David taught us this exact question. So I'm hoping it comes useful. Sweet. So we get the set of unique colors. So now we have red, blue, green, and pink. So we look through it. Red's not anywhere. Blue's not anywhere. Okay. We only have one of each. I'm a fan of it. But if we look over here, I have a list of colors that appeared on my screen, but there's multiple of the same. And let's say I want to print a list of unique colors. Well, it's going to be a bit harder. What we want to do is we can also turn sets into lists. So we're going to say list of unique colors, and we're going to do that. So first thing we know is we want to make a list. But what do we want to make a list out of? We want to make a list out of the set of colors, and that way it stays unique. We look over here again to see what the problem is. Syntax error. Okay, well, there we go. I forgot the comma. Definitely don't do that. Okay, so it makes sense. So we make a set of colors and then we just turn it into a list again. So because we do this, we know that the set's going to make it unique, and then we turn it back into the data structure we want, which happens to be a list. We run it, and there we go. So we could tell by the square brackets that we know that it's a list, and if we look, everything's going to be unique. So the only con that I'm definitely not going to hide is that we did scramble the list a bit. And that's almost to be expected. Because if we look over here, the first entry is green. Okay. The first entry in colors is also green. Then we go, okay, blue. Well, that sucks. Because the second entry in colors is red. And because we use a set, and inside of the set, we have it so that, sets do not care about indices and they do not care about order. The order of the colors got scrambled. So an approach to make sure that they have the exact same order would be to append to lists and make sure that whenever you append, that the value has not already been there. But there is no way anyone's ever going to want you to do that. So I'm not even going to try to teach it. So I hope that gives a bit of insight on, for an example, when to use lists, sets, and tuples. Lists, if the indices matter, and if order matters. Sets, you could get away with them, and you should use them if you see the keyword unique. Then tuples. Tuples are a special case because they pretty much do the exact same thing as lists, but they're immutable. So if you know what you have to do is return something and you don't want whoever, because you're sharing code with someone, you're both working on the same project, and you return a list inside your function, and you know that the person who's going to get the list is going to try to edit it, but you don't want him to, might as well use a tuple. So the lab definitely gives good insight on an example of this, and that would be returning coordinates, because it doesn't make a lot of sense to change the coordinates when it's been returned. It doesn't make a lot of sense to add a new entry to those coordinates, because if you're dealing with the XY plane, it doesn't make a lot of sense to add a Z into there. So this is a bit of insight. This is definitely going to come in handy, whether you're any type of engineering. Data science is going to be used everywhere. And even if you don't go into data science, I know a lot of people in mechanical engineering take jobs from aerospace companies that's automating stuff. And that's a lot of the times done in C++. But having the knowledge down in Python is a really good place to start. So that's about it for me. I'm going to exit out of this and send the solutions over. So, yeah. Thank you, guys.
Cool. So that is like the end of our scheduled programming. I got another. I have a little example question. If you guys would like to cover it, let's see in the chat if we got interest for another example problem, or should we wrap it up and everyone's just tired and trying to take a nap and eat a dinner. We got some feedback in the chat. If we want to go over some more example questions, sure. We got some people who are in faraway time zones, so big respect for being strong and powering through this, because I know it could be deep into your typical sleeping hours. I have a example question. I'll pull up my wing. Okay, hopefully you all see my wing. I got an example question. So suppose that I'll zoom in so it's a little bit more clear. Okay, so let's say we got vectors. Are we all familiar with vectors? They will be very useful in a lot of your engineering classes. Mechanics or statics, dynamics, circuits, linear algebra, all of these things involve vectors, and vectors are super useful. So let's say we know that we got to add vectors, or vectors can be in rectangular form, right? So let's say a vector, we can represent, let's say, a three-dimensional vector. Let's say it's x value, y value, and z value. Okay, suppose we got this as a vector, and it's going to be a tuple. Adding vectors is just, I'll write that as a comment, or resultant vector, vector sum, is just, you add, is just like components added together. Okay, so this is our problem. what we want to do. So given a list of tuples, return our list of vectors. Vectors represented as three tuples, meaning 3 units long. Return the resultant vector sum. Okay, so let's follow our function design recipe. So, of course, a little bit out of order. So some vectors, and this can be a vector list. Okay, and let's fill in a docstring. We first wanted to start off with some examples, right? So suppose we have a list that is full. Oh, that's a set. A list that is full of a tuple that's like 1, 1, 1. That could be one vector. 2, 2, 3. That could be another vector. These vectors can have negative numbers. They can have float numbers inside. So like negative 0.5. Negative 5. Negative 55. And we would expect the results of this to be like all the x. It should be a tuple, and it should be 3 values in the tuple. So the first value should be like all the x values added together. So that'd be like 1 plus 2 minus 0.5. So that's 2.5. The y value of the return tuple is going to be likewise something similar. It's just going to be 1 plus 2 minus 5. So that's negative 2. And the z component is going to be 1 plus 3 plus negative 55. So we got 4 minus 55, negative 51. Okay, so that would be an example. Maybe want to do like maybe another example is that if we get an empty list, well, it's just return 0, 0, 0. Okay, let's get a description for this. So this is like given a list of. Hey, it's almost like it's already given to us from our problem statement. That's a kind of easy way that you can deal with the description part of their function design recipe. Is just pull it out of your question directly. Okay, and now let's clean up this function header. What type is vector list? Well, it's certainly going to be a list. Now it's not super important for you to specify what's inside of the list. You're fine to just leave it as like list like this. Okay, and we know the return type is going to be a tuple. Okay, so I'll show you one of my preferred strategies for handling complex questions like this. So first, we want to basically write out a plan in comments. So what do we first want to do? We're gonna want to make some counters or initialize some variables to hold like our x, the sum of all x's, the sum of all y's, and the sum of all z's. So initialize all variables to store the sum of x, y, z values. Okay, so that'll be our first step. Once we have that, we want to think about what's next on the list that we got to do. So if we have counters for to hold the x value, the y value, and the z value, like those would be the running totals, we're going to want to pretty much start looking at the individual tuples inside the list, and we're going to want to start looking at them individually. So let's say we want to look at the tuples in the input list individually. Okay, now once we're looking at each element in the input list individually, we are going to want to extract the XYZ, whoops, not that, XYZ values, and add those to the corresponding totals. Extract the current tuples. Extract the current x, y, and z values because there's going to be multiple tuples to deal with, and once we have that, once we extract it, we did that for every single tuple. We can just return the tuple of totals. Okay, so writing out the game plan and comment, it's a lot easier to just fill in like the in-betweens with code as opposed to like trying to write the code and trying to keep the plan in your head at the same time. Maybe you can get away with not writing the comments here, but as your complexity and the projects that you're developing increases, this will be a lifesaver because you pretty much give yourself a to-do list, and then you just look at everything on that to-do list individually. It's easier to deal with as opposed to trying to keep it all in your head, because the human brain only has so much RAM before we start to encounter problems. Before this, we gotta include we gotta deal with the empty case. Actually, I don't think we need to have special behavior for the empty case, because if we initialize all these variables to 0, if the list is empty, it's not even going to go through the loop at all if we have a for loop here, and then it's just going to like return the totals. So I think this will actually accommodate all of our cases. We just want to have like a precondition here to say precondition list is full of tuples only. Each tuple has 3 numbers in it. No strings, no booleans, any of that. That's going to make the precondition mad, and that's going to make me mad because the function is not going to work. So we gotta have the precondition to make sure that everything's going to work properly. Okay, so now let's fill in the blanks between these comments that we left. Our comments are our game plan. So initialize variables to store the sum of x, y, and z. I think a nice name could be x underscore total equals 0. Let's initialize all of them to 0 because, well, it's a running total. We have to start them somewhere, and 0 is the most appropriate place for them to start if they're a running total. Y underscore total, z underscore total. Okay, so that pretty much wraps up everything that we got to do for this little step on our to-do list. Okay, what's next on our to-do list? Look at our next comment. Look at the tuples in the input list individually. Well, the key word here is input list individually. Hey, let me think about this for a second. How can we deal with this if it's a loop, maybe? Now, if we want to look at the tuples individually, it's actually, I feel it's going to be easier if we do a loop like this. For element in, what was the name of the input list? Vector list. Vector underscore list. So this is essentially going to say, in the vector list, we're not doing range. It could work out if we were using range. It's just we'd have to do like the indexing, and that's like an added layer of complication that we don't really want to deal with. So let's just do looking at the elements directly. So the first time through, it's going to take on this value. The second time through, this value. So third time through, this value. All that fun stuff should be fresh in our minds with what my colleagues were speaking about earlier. So every time we see an element, we want to increment our, this right here, the loop itself, that's looking at everything individually inside the input list. And now we got to do the next thing on our list, extract the current x, y, z values and add those to the corresponding total. Okay, so to add them to our corresponding total, let's do x first. X underscore total. How do we add something to it, maintaining the previous value? Plus equals. Actually, I'll do equals x, and the next one I'll do plus equals. Both of them are perfectly valid. And the current thing that we're looking at, actually, I'll change the name from element to current tuple. You can name these whatever you want. Oftentimes, people will use I because I is nice and short to type. But if you have a descriptive name, it'll be nice and clear to you what is going on. So we know that the x value is always going to be the 0 index of the tuple that we're looking at. So in this case, it'd be 1. It'd be 2 in this case. All that fun stuff. Awesome. So we're going to do that for the x. We also got to do something similar for the y. Y underscore total plus equals the current tuple, the 1 index. You're perfectly good to use plus equals or equals itself plus. Whatever floats your boat. Most people prefer this because it's a little bit less typing, and time is likely going to be tight on your exam. So, if milliseconds matter, write as short as you can. And then we're going to do something similar for z total. Total equals the current tuple, but the 2 index, which is going to be the third thing in the current tuple. Okay, so that is going to extract the x, y, and z values, and it's going to add them into the corresponding total counter. Looks good. And once we do that for every single tuple inside the vector list, that just leaves us with the last thing on our to-do list. Return the tuple of the totals. So let's return the tuple of the totals. Let's just do return and a tuple of the totals. So what we have is the x total. Well, x total. We give it a nice name like x total, and it is very immediately obvious to us what it means. That's why having descriptive variable names is the way to go. Y total and z total, and that should be good. Zoom out a little bit. This is our whole function. Let's actually make this example make sense. Sum underscore vectors. Say with this one, sum underscore vectors. Awesome. So let's save this. Let's run this. Hey, does it work out? Let's see. Does it give us exactly what we expect? It sure does. 2.5, -2, -55. Wait a minute. Oh, yep. Someone left a comment saying plus equals. You are absolutely right. Without the plus, we will get issues on that. Very good catch. Yeah. Now it should give us what we expect. Awesome. -51, -2, and 2.5. Super. With an empty list, I expect to see strictly zeros in the return tuple. And would you look at that? We got a function complete, and it's party time. And we are happy that our function is done. We are all Gucci. Sounds good? Cool. That was the only practice question that I had on deck right now. We've been going for a long time, almost 4.5 hours, but we were also fighting technical issues along the whole road. My apologies for that. It's really on us that we should be sharper, but we're also students. We also got classes going on. It's tough, but of course that's no excuse for giving an imperfect service. Okay. We'll keep the stream going for just a little bit. If anyone has any last minute questions, I'd be happy to address them right now. Otherwise, I think I will end the stream. Appreciate the support, everyone. Yeah, always glad to help. I'll let the TA know about the other TAs know. Okay, we got one question about someone asking about exercise 5, lab 10. Okay, I'll cover that real fast and then I'll wrap it up. Exercise 5, lab 10. Is that the thought? Is that that's sum 13? I can go over it real quick though because I'll pull it up. See you learn. Yeah, I got you with the lab 10. I just gotta load it up ASAP fast. Hopefully still streaming. Yep, stream is still hot. Lab 10, exercise 5. Okay, lab 3, lab lab 10, exercise 5. But I'll need to do a little bit of a variation because I'm not allowed to directly give you the answer. So instead of 13, we'll use something like 5 instead. So instead of sum 13, let me just format this question out. Okay. Okay, and every time we see 13, I'm just going to replace that with a 5. So it's just because gotta follow the rules of the land. Okay. Okay, so let's follow the function design recipe. Hold up, on the chat it says, didn't they go over it using if statements, not loops? I don't think it's possible to solve this question without a loop. Because you do need to look at every element individually inside the list. You have no idea what the size of the list is before you get it. So because of that, it's impossible to do this without a loop. Or it's impossible to do it correctly without a loop. Okay, so let's start off with our function header, def sum 5. It's essentially the same question, except we are not going to be using sum 13 because that is a copyright violation. Okay, so let's start off with some examples. We can pretty much rip them out of the function description itself. So boom, boom, boom. Sum 5 of that. We would expect to see that gets disqualified, that gets disqualified, 2 plus those 2 disqualified, plus 1. So it's 2 plus 1, you'd expect 3. And for this example, boom, 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 sum 5, boom, boom. And for here, we'd expect to see 1 plus 2 plus 2 plus 1, 6. And the 5 at the end gets not included in there. So here we got to say for the description, we want to have given a list of numbers. There might be floats, but our examples are all integers, but we got to be ready for floats in the event that is the case. Given a list of numbers, return the sum of all numbers that are not 5 and that are not 5 and not preceded by 5. So if you've got a 5 in front of you, you're disqualified from the counter. Our input to this is going to be a list of numbers. Maybe we can call that list of nums. I think that's a reasonable name. And that's going to be a list. Don't got to specify what's inside. That's not super important. Not for this course, at least. For future courses, different story. And we're going to return a number, let's say float, because it is possible that because we want a list of numbers, they might give us floats. So we got to accommodate the fact that if we get even one float that is included in our addition, we got to have we got to return a float. Okay, so we got our doc string down. Now let's think about our strategy for handling this. Let's write that out as comments first, and then once we got out all the comments, we can turn the comments into code, and that should be a little bit lightweight, or a lot more lightweight than trying to write the code without knowing exactly what our plan is. Okay, so let's write out the plan. The first thing that we need is, regardless, we have to look at every element inside the list individually. Look at every element in the list individually. So my idea for how to do this is, let's say we have a variable, a Boolean variable, to keep track if we're ignoring things into our addition or not. There are multiple ways that we could do this. We can do it with like a Boolean flag, or we could do it by checking the thing immediately behind us. I think the easiest way is to check immediately the element behind us. That's going to be easier than a Boolean flag, but both are possible and both are perfectly valid answers. As long as you always get the right answer, it doesn't matter how you do it. If you always get the right answer, it might be slow, but we cannot deduct you on things that work. So keep that in mind. We can do a Boolean flag, but I think this will be easier if we look at every element in the list individually. We don't want to look at the starting. We want to look at the thing before it. If element is 13 or preceded by 13, actually let's put that on a separate line, because that's going to be a different thing. If the element is 13 or preceded by 13, don't include in the running total. Hey, we mentioned running total. We have to define a running total before we even start this. So even up here, let's add another comment that says initialize a running total for the included numbers. In the chat, I see someone has a question mark saying, or has a question saying 5. Not quite sure what you mean by that question. Feel free to elaborate, and I'll come back to that. But we're doing sum 5 because doing the actual lab exercise sum 13, that's going to be illegal. Oh, my bad. I know exactly what you mean. 5. Okay, I got you. We all good. We good. Yeah, if the element is 5 or preceded by 5, don't include it in the running total. Perfect. Good catch. Thank you very much. Okay, so we are going to initialize a running total, and we're going to still look at everything individually. If we see a 5, ignore that. If the thing before the thing we're looking at is a 5, ignore that. Otherwise, include it in the running total. And at the very end, return the running total. Okay, so we got basically our game plan of how we're going to handle this problem. Let's fill in the blanks with code. So initialize a running total for the included numbers. I think a variable named total is very reasonable. The name is perfectly descriptive of what it represents. So that's what you're looking for with a variable name. If it perfectly represents the variable if it perfectly describes the variable that it represents. Okay, now we got to look at everything in the list individually. Our input is a list. If we want to look at the stuff, let's think. So we're definitely going to do like for. Now let's think about this a little bit more. We want to check the element itself, and we also want to check the element that is before it. That's going to be a lot more difficult if we do a for loop looking at the element individually. It's going to be a lot easier if we do the indexes, because we have to look at the thing before it before we even look at the current. We have to consider is the one before me a 5 or not, yes or no. So it's going to be a lot easier with an index. So let's set up our for loop to be like for index in range. Now if we just do len of list of nums, an issue that we're going to run into is that the very first thing that we look at, we're going to try to look behind it, and that's going to be an issue. So we'll actually start this off at 1 instead of starting at 0. So it will start off at the second element in the list and then onwards. Okay. But since we're starting at the second in the list, must still consider the first element as a special case. Okay, so to look at the very first element in the list, we also have to make sure that the list is not empty. So if the list is empty, we should just immediately return 0. Empty lists cannot have their values referenced. That would be an error. So we need to have special behavior for empty lists. So how do we tell if the list is empty? Well, if the length of the list of nums, if the length is equal to 0, we know that the list has to be empty. And if the list is empty, well, we're certainly going to have 0 as the sum for everything that we're adding inside. Return 0. And actually, I'll move this down here so that we're only going to initialize that when we know that we have something that's not empty. Sounds good? Sounds good to me. Okay, now that we have something that's not empty, we got to do what happens when if there's only one element in the list, we should return that what's in there unless it's a 5. The reason why is because if we have a list that is only one element long and we start this for loop, this is going to be an error because it's going to try to do the index at 1. That's going to be problematic. So we need another special case for lists with one element will not survive the for loop, or will cause an error in the for loop with like list at 1. So we got to deal with the one element list separately. So upstairs we have an if. Well, let's do elif. It's good to use elif anytime you know you have like an if section and you know that you can only go down one of these paths. Use elif. So else if the length of list of nums. I'm gonna copy paste that so it's not. It's a little bit easier to type that out. All like 10 letters of that. And that's equal to 1. We have to we're going to return the only thing in the list if it's not 13. Otherwise we're going to return 0. So we can have a nested if statement. If list of nums of 0 is equal to 5, that means we're going to return 0. And if it's not 5, we can just hit it with the else. Return list of nums 0, which is just the first element. In this case, the only element. These nested if statements, don't be intimidated by them. It just means that you're only going to do this if when the elif above it goes true. So this is basically just the body of this. You can nest as many if statements as you want. Yeah, it's fun stuff. Okay, so now that we deal with our special cases, we should initialize our total depending on if the first element in the list is a 5 or not. Initialize the running total for the included numbers as the first element in the list. 0 if it is a 5. Okay, so let's have another if statement. We can do since the ifs and elif above us like those paths always have a return. We can just use if because we know that we will only get here if we don't have a return upstairs. So assuming we don't go down any of these paths, we're going to get here. So if and if we get down here, we know that the length of the list is 1 or more. So if the first thing in the list is equal to 5, we're going to initialize total to be 0 because 5 is the number that we want to disqualify. And we can hit it with an else because anytime that it's not a 5, well, total is just going to be equal to the first element. The 0 index, the first element. Does that sound good? I think it sounds good. So we initialize this because when we check in here, we're going to start at the second element in the list. And if it's 5, ignore it. If it's preceded by a 5, ignore it. Otherwise, include it. Okay, so we can do that with an if statement. And now, keep in mind, we're inside the for loop. So we already initialized total, depending on what the first element is. And now we want to deal with this. Okay, so we want to be looking at every element in the list individually now, or from the second onwards. So when we're looking at an index, when we're looking at something, we want to check like if the current thing that we're looking at, so that's a list of nums index, is equal to 13, or a list of nums index -1. That means the thing before what we're looking at right now. And we always know that since we're starting at the second element of the list, we have the check here. Oh, yep, you're right. Not 13. It's going to be 5. Very good catch. And for this, if that is equal to 5, do nothing. Ignore this and move on. Let's actually think about this for a second. Now, does it make sense to have like if, the disqualifying factors are true, then like have nothing inside here. I think it's actually going to make more sense if we do like, if we're not looking at a 5, and if and the thing before us is also not a 5, then we're going to include what we're looking at right now into our running total. So that will just be total plus equals, boom, list of nums at index. The index is the current thing that we're looking at. And we're checking to make, before we add that, we got to make sure that the thing we're currently looking at is not a 5, and the thing before us is not a 5 as well. If that proves to be true, we're going to have that into our total. And we're going to do that every time we have a different index, all the way until the last index in the last element of the list. Sounds Gucci? Okay, awesome. So after that, after we get through this entire list, well, our total is set up. So I think that means that we're just good to return the total. And how we do that? Well, return total. Shocking, right? It almost makes too much sense. So I think that's a function complete, because we know that, just as a recap, empty lists, we're going to deal with that as a special case. When the list only got one element inside, we're going to deal with that as a special case. Otherwise, we're going to check. We're going to initialize our total to be the first thing in here, and then we're going to check everything before. Or we're going to start the loop looking at every individual element. If we're looking at a 5, we can't be looking at a 5. If we're not looking at a 5, and the thing before us is not a 5, we're going to add that to our total. Now, I see in the chat, my pleasure, I'm glad to help. Using it with while loops is definitely valid as well. And the question I had before that is, what if we wanted to index at index +1 instead of -1? The issue is that our question is saying that we have to disqualify things when the number before them is 5. It's a little bit more out of the way if we wanted to check afterwards. Because let's say we encounter a 5, which is our number that's going to cause our disqualification. Checking afterwards is, I guess that's going to tell us the next thing that we're going to ignore. But I in my opinion, it's going to be significantly easier if we just check what's before us and then do it that way. I mean, if you did it with index +1, you just have to you could make it work, but it's going to be a little bit more difficult. A little bit more out of the way. Now, before we just celebrate this, don't celebrate a function complete until you know that it actually works properly. So let's run this through the test. Hopefully we'll get a 3. Oh, we absolutely do get a 3. Let's try this example. Hopefully we get a 6. Oh, would you look at that? Let's do another test. Let's say a list that is full of 5, 5. Whoops. I just will keep that 1, 1, and then a whole lot of 5s, and then a 55, but that will be ignored, and then 1. What should we expect out of here? We should expect 3, because all of these and that 5 there will be ignored. So let's see what happens. Will we get 3? Oh, would you look at that? We do get a 3. I think we are safe to say that it is party time because we have a function complete. Sounds good. So my dinner is I can hear it downstairs. I think I do need to wrap up the stream for now, but I've had a blast helping you guys out. I hopefully that myself and my coworkers were helpful, and hopefully we all feel prepared for the exam. When that comes, having Wing open to test some of your stuff is definitely going to be a great tool to have, especially since it's open book and that's all allowed. But I have a strong feeling that the exam is going to be tight on time. So given that it's going to be tight on time, you hopefully are able to act as the computer in your mind, look at code, and then see, and then kind of know exactly what would happen without testing it yourself. So that's a very important skill to have that will increase your ability to go through their exam at high speed. And if you go, the faster you go through your exam, the more you'll have time to go back, review the things, and make sure that you didn't make like a sign error or like do equals instead of plus equals like I did once. Because those small errors are what will kill you. It's typically not like, I mean, if you have big laps in your knowledge that you don't know the core concepts, you're toast anyways. But the people who are really sharp and who know their stuff, they get killed by small mistakes. So you want to be able to hopefully have some time at the end of your exam to review everything that you've written so far to make sure that everything is working precisely like you designed it. Okay. I appreciate the praise. It's my pleasure to help. I'm sure my coworkers would say the same. It's what we're here for. We're here to help you. And I'll try to have the video posted of this entire session within the next 24 hours. It kind of depends on how fast my uploading is going to be. But had a great time tonight. Hopefully you all feel prepared for your final exam. And I'm going to end the stream right now. But I hope you all have a great weekend. Enjoy the Halloween safely. Pandemic partying, that's kind of sickening in more ways than one. So stay safe. I hope you all have a great weekend. Enjoy your Halloween safely. Maybe dress up, in the mirror, and you can feel like the coolest cosplayer in your own house. That's probably how I'm going to be celebrating my Halloween. But regardless, hope you all have a great weekend. Take care and study hard.